Imagine you are a geothermal energy producer and you just discovered that all of the liquid you're already pumping to the surface is full of lithium. Time to cash in and help the world while doing it. You have the spindle top of the energy transition on your hands, right? If only it were that simple. So let's first talk about why I've dubbed this asset the spindle top of the energy transition. Here you can see the demand for electric vehicles as projected by a recent DOE report. In order to use all of the renewable energy that we have on the grid for transportation, we need to be able to store that energy. And the best option we have for that, for the reasonable future, is the lithium-ion battery. So why is this a problem? This is a problem because there are huge gaps in the lithium supply chain for lithium production and refining, especially domestically. And in fact, the first two goals of the national blueprint for lithium batteries are dedicated to this gap. So back to our operator. He wants to be able to capitalize on this opportunity and help fill that gap. But there are huge challenges with processing his brine from its raw form to a product that's ready for market. And that's because the commercially available technologies are expensive to install and operate, are inefficient at removing other contaminants from the brine, and generate large volumes of hazardous waste, which are under intense scrutiny by regulating bodies, especially out in California, where a lot of this production is taking place. Fortunately, here at LiQuidium, we have a solution for that, which our technical lead, Terrazzo, will share with you now.
We help geothermal energy producers extract 30% of lithium from their brine while generating 85% less chemical waste by installing our ultra-degradable lithium-selective membranes at 1/3 of the cost of current state of the art. The LiQuidium membrane developed at the University of Houston through NSF funding has high density of functional sites which are specifically designed to transport lithium and only lithium to their M-size pores. Our technology is enabled by a novel additive manufacturing technique which will significantly reduce the cost of production compared to other lithium-selective active materials. Currently, solar evaporation dominates the market for lithium extraction from brine. However, this process is inefficient and consumes large volumes of water. Direct lithium extraction is going to be the newest state-of-the-art, and it is currently achieved in 1 of these 2 ways. Solvent extraction and absorption are expensive, and they usually generate large volumes of hazardous waste, which requires a lot of money to dispose of responsibly. Ion exchange media is expensive, and the process itself is very energy intensive. LiQuidium technology can improve on all of these processes in order to increase the quality of the end product and also reduce the upfront costs and end-of-life waste. Now let's see where this technology can be employed.
According to McKinsey, global lithium production is on track to hit 2.7 million metric tons of lithium carbonate equivalent by 2030. The Mineral Commodities Summary for 2023 identified a total addressable market for all global lithium refining at $5 billion per year. Since the LiQuidium membrane is uniquely suited to brine-based lithium resources, we've identified a serviceable addressable market of $3.3 billion a year for global lithium-containing brines. Since we have US-based operations, we are targeting a serviceable, obtainable market of all US-based brines to fill that critical supply chain gap we discussed earlier. Now, the US lithium extraction market is relatively young, with only about 1,000 tons of lithium produced last year, but the USGS has identified over 750 million tons of economical reserves for a total value of $28 billion, and that's a conservative estimate at today's prices. Recent venture activity in the space confirms the growth projections for a US lithium market as shown on the last slide, and sends a strong market signal that innovation is needed in this space. So within this market, there are a number of growing sectors, including geothermal, mine tailings, and oil field brines. LiQuidium has identified geothermal energy producers, and specifically those with existing lithium extraction business units as our beachhead market. For us, a natural follow-on market will be new build geothermal, And in fact, Criterion Energy Partners out of Houston, Texas, is providing us with a letter of support to supply brine samples to help our ongoing R&D processes in the lab. A second follow-on market for us will be oil field brines, an industry which is already ramping up production in the Gulf Coast region of the US. So what will a LiQuidium install look like to these customers? We will penetrate our beachhead market with our minimum viable product, a LiQuidium membrane module, by piloting and then retrofitting at existing geothermal lithium extraction sites. And then once we have a footprint established with these customers, additional membrane modules can be added on schedule with the media replacement cycles of the incumbent technology to completely replace it, while allowing our customers to retain a lot of that capital investment they made in the overall infrastructure, including pump stations and pretreatment systems. Meanwhile, LiQuidium will be building out a full-service direct lithium extraction platform, including pretreatment services, system-level controls, and remote monitoring. And our finance lead, Pranjal, will share more about that now.
Our business model is based on a leasing model to decrease the barriers to entry. Our initial customers will be geothermal operators with existing lithium capabilities. We'll be providing training, maintenance, and diagnosis year-round. Unit pricing will be based on customer value-add basis of how much additional lithium can be captured, seen through our customer discovery interviews. We expect LiQuidium to be cash flow positive 2 years post-pilot, just around the time we expect a 30% penetration of our beachhead market. After initial success with geothermal operators, we'll expand into other verticals, creating a resegmented market ready to grow because of our ability to make operations economical with the lithium add-on. By 2030, we expect to provide 25% of domestic direct lithium extraction. Now let's walk into implementation. This is controlled thermal resources in a plant out in the Salton Sea. Implementing LiQuidium's technology into the current business process, we see an 85% reduction in chemical waste and a 13% higher IRR. In the bottom right corner, you'll see the minimum requirements for an economic implementation of LiQuidium's technology based on the size of our pilot facility. However, because of our modular technology, after penetration of the beachhead market, we can easily make larger and smaller facilities to fit different customers. Another implementation study of an oil field brine, our second add-on market. Implementing LiQuidium's technology and using the same idea, we see a 54% higher IRR into the lower ppm content, seeing that implementation possibility of LiQuidium. Now let us show you why we're the perfect team to do this.
Is there? Oh. Just thinking about that. Okay. I'll leave.
Our founding team are experts in engineered systems design, R&D, and finance. And additional key team members will include a manufacturing lead and a head of sales for our internal direct sales team. During the pre-pilot phase, key partnerships will include research resources from the University of Houston and Argonne National Labs, membrane prototyping partners, SBIR programs, and critically, commercial piloting partners like BHE Renewables or Controlled Thermal Resources out of the Salton Sea region. As we begin generating revenue, additional partnerships will be required, like venture capital partners, community and government organizations, logistics agencies, and equipment suppliers. LiQuidium will contribute to the energy transition by providing responsible stewardship of valuable resources. As we discussed earlier, lithium is an irreplaceable element in the global effort to decarbonize. And in order to make the energy transition accessible to the general public, more sources of economically, socially, and environmentally sustainable lithium are required. And LiQuidium will be a part of that solution. And on the topic of the energy transition, currently 6% of the total US workforce is employed by the oil and gas sector. A new upstream and midstream lithium industry in the US will help provide opportunities for those who may have otherwise been displaced by the energy transition. And with our headquarters in Houston, Texas, LiQuidium will be uniquely positioned to help retrain and capture the expertise and experience of some of those professionals, including geologists, reservoir engineers, and supply chain analysts. And it's also worth mentioning that from a technology development standpoint, EERE has identified ion-selective membranes for applications in hydrogen, carbon capture, and electrochemical synthesis, as well as lithium. So after lithium, the sky's the limit. And with that, we would like to thank you very much for your time, and we would be happy to take any questions.
Great presentation as usual, and great to see you in the national competition platform. First question around, you mentioned that you have 13% IRR. Could you elaborate more on like where it gets into the CapEx and OpEx?
Yeah, I'll actually let Frontal speak to that.
The 13% IRR is based on if you were to use any of the other technologies. And so, for example, Controlled Thermal Resources is using solvent extraction. And so instead of using solvent extraction, if you were to put LiQuidium in, and that's assuming after a quarter you implement LiQuidium into your whole technology system, you get that higher IRR.
Yeah, how much, I'm not as familiar with the geothermal market. How much assumption of growth in that market have you baked into your business plan? Or can you make a profitable business just on the existing geothermal plants today?
So we could make a profitable business based on the existing geothermal plants, specifically out in the Salton Sea region. That's kind of like the main asset that's been studied geologically to the point where I think it's ready for market penetration in direct lithium extraction, and that's where all the piloting for DLE in the US is taking place at the moment. But that being said, there are a lot of startup players in the geothermal space that we've highlighted for our follow-on market that are in the drilling phase now or looking to drill their pilot facility in the next year. So that's why we think it's a market that would be ripe for us to penetrate in a couple of years down the road after our initial pilot.
Just to add on, like on a quantitative basis, in our model, it's like a 5% growth in geothermal, which is very low in comparison to what it's actually going to be.
Great job, y'all. I'm curious, is this truly disruptive or is this incremental to how the industry currently operates?
This is definitely truly disruptive. Direct lithium extraction in general is a disruptive technology as compared to what's being done today. But there are a lot of market indicators kind of begging for a membrane solution, including the EERE put out a FOA recently that we're still in the running for research funding, and specifically pointed to membrane-based technology. And a lot of it's surrounding reducing all of this waste product that's being produced by the other DLA technologies. And also operational efficiencies.
In terms of your implementation, like your membrane, how much does it, like the existing operators that they need to change their current standard procedure? So for both geothermal and your next market, oil and gas.
Yeah, absolutely. So like I mentioned, we are planning to be a drop-in solution to directly replace just like the active material part of that infrastructure that they've already put in place. So we can use existing pump stations, existing pre-treatment systems, and a lot of that other capital investment that they've made. And I think a similar situation will be at foot in the oil and gas field as well, because they're already starting to build some of this infrastructure around technology pilots for lithium extraction.
Have you done any customer discovery, and if so, how did that shift your approach to this business?
Absolutely, yeah. We've talked to a number of potential future customers, and we shifted from an equipment sales model to an equipment lease model based on a lot of their feedback. And they also provided feedback that this lithium selective membrane is very needed in the industry, and that the hazardous waste is kind of their number one issue. But I think the biggest change in our business model was this lease versus sale shift.
And then I think I'm asking everybody this, but sort of what has been demonstrated technically on this so far? How far along are you guys?
Yeah, so we are currently at around TRL 3 for the technology and chemistry in the lab and all of our separation tests. And then we also are developing this new additive research funding at this point to be able to advance that technology and begin to scale the manufacturing process as well. So we're hoping to grow those side by side to be able to scale more efficiently.
Awesome. Well, thank you so much. All right, thank you so much from University of Houston. So to continue my trend, I did think about making a joke about salt, but I thought, nah, that's just sodium. Sodium, yeah. Delivery, I have to work on just a little bit. But our next team, I'm excited to welcome Flux from the University of Wisconsin-Madison. Welcome.
Hello, I'm I'm a PhD chemist at the University of Wisconsin-Madison and co-founder of Flux, which I'm going to tell you a little bit about today. So the clean energy transition is well underway. However, as we replace more dispatchable coal with more intermittent solar and wind, the opportunity for long-duration grid energy storage will exponentially grow. McKinsey & Company estimates a TAM of over $200 billion by 2040. Where this is coming from is as we have overlap solar and wind, we get what we call the net demand curve, so it's shown on the right. Over the last few years, we've been employing lithium-ion short-duration technologies to begin shaving off the peaks of those curves, roughly 4 to 6 hours of duration. However, with lithium-ion technologies, we're leaving the meat of the duck behind. As you can see from what I've highlighted in red, we're leaving over 12 hours of duration of value on the table because there's currently no technology where it's cost-effective to go after that value. So why have we been using lithium-ion technologies? Basically because it's the only technology for the grid that exists at scale and low cost due to Chinese manufacturing of the EV market. However, there's a few concerns being forced for the grid market, including supply chain risk, scaling engineering, and fire variance, which may or may not be overcome. However, one of the things that's intrinsic to lithium is its short duration limitation, roughly 6 hours. When evaluating different long-duration energy storage technologies, aqueous flow batteries are potentially really ideal. One, they immediately eliminate the fire risk because you dissolve your battery active material in water. They're a lot more scalable for grid energy storage, want more energy, just get a larger peak of liquid. But one of the key points is they have long-duration cost economics. The analogy I like to use for this is kind of the driving range of your electric vehicle. For lithium-ion, if you want 12 hours of duration, you have to buy 2 lithium-ion cars, 2 lithium-ion systems. For flow batteries, you can buy a car that drives for 12 hours on the grid, and as a result, your economics versus duration increase less dramatically. A lot of studies out there by utilities and nonprofits and consulting firms show that if a low-cost, long-duration technology exists, as in this top line scenario, it will dominate the grid energy storage market through 2040 with roughly 2/3 market capture. However, with current flow battery technologies, we're batting in this bottom box here, well, lithium-ion batteries will continue to dominate the market, once again, because it's not cost-effective to go after the remainder of that curve. This is because of multiple reasons, whether it be using rare earth metals for the active material, just longevity issues out on the grid, or just overall poor performance that can't compete with lithium-ion. This is the challenge that my team out of the University of Wisconsin-Madison has been addressing over the last few years, including myself as a PhD chemist, Guhan as a material engineer, and Austin with chemical engineering expertise. Kind of our innovation strategy over the last few years, it's kind of twofold. So one, we've been screening all the competitor existing chemistries, really diving into the understanding of their mechanisms and developing novel enhancements for existing chemistry. However, at the same time, we've been developing the library of these organic redox active materials. These organics are carbon, oxygen, nitrogen based, and can be molecularly engineered to have the properties that you want. So we designed a library of hundreds of new chemistries, screening their flow battery properties, and demonstrated record performance on one of those lab scale devices shown right here, in terms of stability, efficiency, and density. We realized that addressing the grid energy storage market, scaling will be our primary risk moving forward. So we've taken initial steps to try to address this concern moving out of the lab. We've taken some of those organic salts that I talked about, used our patented grid synthesis technique, and have worked with partners to do one-ton industrial reaction for those organic salts. We're validating the performance of those materials There's a lot of grid energy storage companies out there, as I'm sure you're a lot aware, a very competitive market. However, I kind of classify them in two buckets. So there's those that use rare earth metals that can be quite expensive, but they have really high performance, such as lithium ion or vanadium flow battery. Then there's another bucket where you can have these low-cost materials, such as iron, zinc, and chromium. Those are low-cost materials, but they have all sorts of performance issues associated with them. They're sacrificing with these materials. Really, the first solution coming to market that will be low-cost materials that are scalable with improved performance over any existing technologies. We've had a third-party analysis done by the energy firm DNV. We corroborated our large-scale performance. Some of the highlights shown here on the left. One is we're operating at an energy density of 50 watt-hours per liter. This is how much energy can you fit per volume of liquid. This is roughly 3 times that of commercial flow battery systems, and really approaching with great lithium-ion battery systems. Another big drawback of commercial flow batteries is they're usually operating around 70% round-trip energy efficiency, when being explored with lithium-ion operating over 90%. We can operate well over 80% and even approaching lithium-ion at lower power ratings. Once again, we're using water as our electrolyte, which is non-flammable, but also we utilize a pH-neutral solution, which is non-corrosive. This reduces your spillage risk, but also more importantly, allows us to use cheaper, more robust components during our device. Preliminary techno-economic analysis, this is total cost of ownership shown here, predicts that we can significantly undercut the cost of current flow battery technologies once scaled to utility sector. What this means in terms of our customers is going back to that duck picture. We're kind of right now operating in this green line and will be for the near future, where we're just shaving off those peaks. However, with these economics, we can start to capture that remaining value under that peak and get these flat loads. This will also unlock additional value in terms of capacity credit, arbitrage value, power purchasing agreements, and as well, this can do a lot of other functions with lithium ion, such as frequency regulation. So kind of where we're at in this development is that Lawson and Wuhan still have some work to do to finish up the degrees, but I'll be starting full time on this. In the summer, we're looking to raise our pre-seed round so I can build a full-time team tackling this challenge. One of our main deliverables will be manufacturing this 20 kilowatt system. I like to call this our Lego block to build out larger systems. If you crack open one of those shipping containers, you'll see a bunch of these stacks stacked together. And I also want to start forming relationships with manufacturers for both the device and the chemistry to manufacture this technology onshore. Here's some of the partners that we've talked to, as shown on the bottom. And right now we have an ongoing collaboration with Argon to develop some of their chemistry as well. Kind of our channel to market is first we're going to really scale as quickly as we can, as cost effectively as we can, to a megawatt pilot. There's endless applications for this megawatt pilot behind the meter, such as with Intech Solutions, who does microgrid integration, or US Ventures, who's analyzing this technology to support their renewable energy goals. This is really what utility scale contractors, those project developers, want to see before they would ever sign on for a large utility scale contract. And so we're hoping that we can compete for these contracts starting in 2030, when this market, long duration, is really expected to boom from 0.5 terawatts to over 2 terawatts 2030 to 2040. And I'm really excited for the impact that this technology can have. One, because there's really no ideal product on the market for these customers today. By utilizing more solar and wind, we can reduce our greenhouse gas emissions on the grid. One of the things I'm personally more passionate about is increasing energy resiliency and equity by having more affordable distributed assets out on the grid. And by using these organic salts, we can really have a more secure supply chain for our critical battery materials, which is in line with a bunch of DOE and White House goals right now. Thank you for your time, and I'm happy to take any questions.
Thanks, Patrick. So you mentioned that in your kind of utility scale, you're looking at potentially 2030, and then I saw that your kind of first pilot for 1 to 10 megawatt pilot project, you're looking at 2026 to 2028. With other companies like Entura, Ford, other competitors that I have listed over there, they have been kind of going full speed, like getting to the low cost and for long duration storage. How are you going to kind of bend your own curve so that you can catch up once you're ready to get your project online and still be able to compete with them?
Yeah, so one thing I would say is there's also a lot of examples of failed grid energy storage companies because they did not scale smartly at the right time. Kind of 2030 is what we really see as the breaking point for this market. So if you actually look at the analysis, there's really not much value
make sure I understood. In your sort of R&D slide, you talked about analyzing the existing kind of chemistries and improving them and then developing your own. What you're talking about here, commercializing, is your own novel chemistry?
Yeah, so for example, I can show you some of the ones that we have published. So we develop all like hundreds of libraries of these organic materials. You kind of make an analogy to the pharmaceutical field, where you can have hundreds of these derivatives. We screen all sorts of different properties. So yes, the ones we'll be commercializing are kind of some of these organic salts, as well as potentially some of these enhancements that we have added into the systems as well.
Sorry.
No, go ahead.
I was going to say, piggybacking up of Craig, is there anything proprietary about your membrane or how your batteries configure?
Yeah, so one of our main advantages is that since we have this library of all these active materials, we can really bring commercial membranes, so we don't have to worry about developing new membrane technology. We do have provisional for some membrane technology, but that's kind of down the road development phase. Right now we can use a lot of existing commercial membranes.
And you also said that your system uses less energy. Can you explain to me why that is?
Yeah, so one of the main properties we've screened is their kinetics. One of the main issues with any inorganic metal flow battery is that their kinetics are extremely sluggish, so they waste a lot of energy, poor energy efficiency at the electrode. We don't have that issue at all. So we have no limitations on what sort of power performance and energy efficiency we can get out of these.
You talked a little bit about the climate justice aspect of this and having that be a focus. Can you talk a little bit about the practical applications and what sort of change this would make for different communities?
Yeah, so one of the reason we're talking to utility scale is because we need to reach economies of scale first to compete with lithium-ion batteries. However, once we reach that cost target, I think I'm really interested in exploring this microgrid market. I've done an SFI for exploring that market. Some examples we've talked to out in Wisconsin are Travel Nation, Better Earth Track are kind of pioneering these microgrids, to be honest. They see the value of energy independence and resiliency very strongly. There's a lot of cities, municipalities analyzing this as part of their security plan as well too. So one of Wisconsin cities is implemented back in 2018, lost all sorts of power, lost all sorts of money from that grid. So they're also utilizing microgrid. Great question. Awesome. Yeah, no further questions. Thank you for your time, and I really appreciate it.
All right. So hello again, everyone. And so we were thinking about one more joke, because why can't I do that while we transition? It looks like we have a demonstration as well. But what did the resistor say to the capacitor after he beat him in a game? I owned you. Okay, it's getting worse as the day goes on. But that's all right. We'll survive together. So I'm excited next to introduce Pike Robotics, the University of Texas at Austin, and we'll bring them around to this side for some steps. So welcome to Pike Robotics for the University of Houston.
Hi, I'm Connor Crawford, CEO and co-founder of Pike Robotics, coming from the robotics portfolio pro at UT Austin.
Hi, I'm Frank Riegel. I am the Chief Technology Officer and currently a robotics PhD student at UT Austin. Pike Robotics is a robotics inspection service provider that inspects critical equipment in the hazardous and Class 1 Div 1 environments. Pike's technology stems from the technology that was developed during a graduate research project over $700,000 by Phillips 66.
So for owners of petrochemical storage tanks who experience difficulty maintaining their floating roof seals, we provide a robotic in-service solution that guarantees safety of facility personnel, reduces operating expenses by 85%, and helps remove around 480,000 metric tons of greenhouse gas emissions by giving energy companies better data about their facilities. So storage tanks are used by energy companies to hold highly volatile liquid product, crude oil, gasoline, jet fuel, and oftentimes they have a floating roof that sits atop the liquid product. Now the purpose of this roof and the perimeter seal is to prevent the formation of and escape of volatile organic compounds. Now, over time, this seal will lose its operational and environmental effectiveness, and in order to prevent failures and planned repairs, a team of 5 humans equipped with oxygen tanks and other PPE must be sent into the tank on a regular schedule to perform an inspection.
Now, there's numerous issues with the way these inspections are done today. One of the biggest is operator safety. Between the years of 2011 and 2018, the U.S. Bureau of Labor Statistics found that there was 205 deaths associated with these confined space entries. Another big issue is cost. Now, it can cost a substantial amount of money to equip and pay for labor for a crew of 5 to get in and inspect these tanks. But the bigger cost is for the tank owners. It can cost up to $2.3 million for a 3-month period of tank downtime for inspections and repairs. Finally, poor data can lead to EPA fines as well as tank fires that can result in devastations such as what we're seeing up in Ohio, as well as what we saw a few years back at the ITC tank farm fire.
So because of these issues, these roof seals are not being properly maintained, making them responsible for 6% of methane emissions in the United States per an EPA study that came out in 2021.
So why develop a solution for these problems now? Well, the last piece yet to be robotically inspected on these above-ground storage tanks is the floating roof seal. The current inspection process for an internal floating roof tank is to drain the product out of the tank completely, costing millions of dollars in lost revenue. There are robotic technologies on the market that can inspect the floors and the walls of these tanks with the product inside, but no one's yet to develop a technology that can operate in the vapor space above the seal that exists when there's product in the tank. But Pike has found a way.
So we've developed an autonomous explosion-proof wall climbing robot that can operate in this hazardous vapor space. The state-of-the-art sensor suite on board the robot collects visual, ultrasonic, and gas concentration data inside the seal. The robot can also deploy a physical resistance probe into the product below to assess the mechanical integrity of the lower primary seal. Now, these combined capabilities allow for a data feedback loop that includes real-time collection and analysis of the seal's health and integrity. So here's a simulation of our robot during a roof seal inspection. Using a magnetic adhesion system, it travels down the wall to a location directly above the weather seal. Our test and motion controller keeps the robot and its insert sensor package in the space between the seals. During circumnavigation of the tank, our system gathers real-time, high-resolution, and continuous data about the state of the seals, including the seal-to-wall gap measurement and identification of any fabric tears. Where's that? Okay. And identification of any fabric tears. Our proprietary software program fuses all this data together, analyzes it, and generates a real-time inspection report. So these 2 features that I mentioned are critical at reducing fugitive emissions.
We can pause for a second. Sorry, you don't want to, sorry. What up? I don't know. Sorry about this, everyone. We can pause and resume. Apologies. It's not their fault.
I don't think I pressed anything. As a robot, I don't take all. Did y'all hear about that New Moon restaurant that opened up down the street? Great food, no atmosphere.
I love it. That was a wonderful. So,
My
we
clean
will
jokes.
make sure that you do not run short on time, and we can find back where you were in the slide. So again, not their team, the computer just restarted. No reason for it, just did.
Hear that Windows sound. Okay. So at the conclusion of this video, we're going to start the next one here.
All right, on your left here, you see the inspection report we provide to the tank owners. This is the only comprehensive seal inspection report on the market today that allows tank owners to provide risk-based assessments of their seals, as well as predict the time of the seal failure.
So here's our robot in live action on an out-of-service storage tank at a fuel terminal site in Waco, Texas. We received good feedback from this initial beachhead customer, Flux Wholesale, and we're going to return for a further demonstration once our system is certified. Doesn't bode well. Yes, sir. So we learned that it's very hard to do that inspection when the roof is very far down on the tank bottom floor. But the cool thing about our solution is we'll be able to do these inspections in service while the roof is 10 to 12 feet above the top of the tank, because these companies like to keep as much product in the tank as possible to keep their operational stream running efficiently. And so we actually have a combined approach we're working on with another companion robot to assist with the tether management. And so that's one thing that we learned from doing that test out of Waco. So, question from the audience, thank you.
All right, here we go. Good? All right. There's 213,000 tanks across 8,200 facilities located worldwide. Based on the distribution between external and internal floating roof tanks, as well as the inspection frequency, this puts our TAM at about $1.1 billion. Now, Pike's beachhead customers are here on the Gulf Coast at the 1,200 sites that have above-ground storage tanks. Based on our calculations, this puts our SOM at $153 million. All right. Now, as our robotic platform gains that hazardous environment certification, we can begin to explore other areas that the robotic technology can be useful for. We can apply our robotic technologies to inspect pressure vessels, distillation pumps, as well as piping. We can even transition this robotic technology into other markets, such as the agriculture, the paper and the pulp, or chemical.
So our business model is robots as a service. There's federal laws that require the tanks to be inspected on a regular schedule. States and local municipalities sometimes require more frequent inspections. Operators in California, for example, must inspect their roof seals 4 times more frequently than that of Texas. So we provide inspection service on a recurring basis utilizing our robotic platform. Now, once an inspection is due upon the maintenance schedule, Pike will send a 1-person crew out to the site to perform anywhere from 1 to 10 inspections per trip. And there are 2 types of storage tanks, open roof and closed roof tanks. Due to our lower input costs around travel, labor, robot construction, costs around $35,000 to build one of these robots. We can offer price points for open roof tank inspections, which are 30% less than the competition. For closed roof tank inspections, there are no competing in-service solutions available on the market today, which allows us to premium price our service offering. Our first customers for the service will be midstream and downstream operators. We already have a letter of support from Phillips 66 and 1 pending from Flux Wholesale, illustrating their desire to use our robot once it is certified. There are also other customers, them being the manual inspection service providers, who recognize gaps in their current service offering. However, these customers are also our main competition.
Our value proposition is clear. We provide a comprehensive seal inspection report to the tank owners to better perform risk-based assessments on their seal. We also provide this inspection with the tank in service, meaning that the tank owners don't need to lose millions of dollars in lost revenue. Finally, we can provide this inspection 8 times faster than the manual inspection process, and with just 1 person standing outside the hazardous environment. This increases safety and decreases costs for our customers.
So our competitive advantages start with our intellectual property. Our robot's novel design and inspection method has 2 patents pending in the United States, and these patents are written broadly enough to protect against any copycats. We recently concluded negotiation on an optional license agreement with UT Austin for the exclusive use of this patent portfolio. There are also a lot of development and iteration that's gone into the safety capabilities of a robot, not to mention the future costs of certification. So this is going to build a moat around our business that competitors will not want to challenge. The trade secrets that we've developed will also be very difficult to replicate. That includes our sensor deployment design, our autonomous navigation capabilities, and our tether management process, as well as our proprietary detection software.
To date, Pike has raised $70,000 in non-dilutive funds from prize and grant money. To round out 2023, we're going to continue with our demonstration program and do 3 more demos, as well as continue to achieve that hazardous environment classification on our platform. By the end of 2024, we plan to have onboarded 17 customers with our go-to-market strategy that Connor will touch on next. 2025 and beyond is all about expanding our customer base as well as exploring other markets our robotic technology can be useful for.
So we'll begin generating revenue with inspections at the Phillips 66 Ponca City refinery in Oklahoma. We'll also onboard smaller midstream and downstream operators who more closely align with our beachhead market. Through participation in a Sprint Robotics Consortium, as well as executing well at these smaller sites, we'll begin to onboard larger customers like the ExxonMobil Baton Rouge refinery. So here's our 5-year revenue projections. By this time next year, we'll begin making money, and by 2025, we'll be profitable. By 2027, we plan to capture 16% of the United States market with a gross revenue of $27 million and a net income of $14 million. I'm happy to talk about the reasons behind these high gross margins in Q&A. So future funding for this venture will be used in 3 key areas: R&D and team expansion, electrical and safety, consulting and testing to get the system class and certified, and travel and setup costs for customer demos. So we're in the late stages of due diligence with a safe note from an early stage venture capital firm out of Florida, SBIR Phase 1 grant from the National Science Foundation, and a corporate accelerator venture program through Shell Game Changer. So through these dilutive and non-dilutive funding opportunities, we're very close to being fully subscribed, and we're looking for this energy tech competition to help us close out this investment round. So our team of engineers and scientists come from the $3 million per year Nuclear Applied Robotics Lab at UT Austin. This group specializes in robotic solutions for dull, dirty, and dangerous tasks in the nuclear, oil and gas, and defense industries for the last 17 years. So this relationship with the lab puts us in a unique position to recruit experienced robotics engineers to tackle more challenging and profitable use cases, like that hydrogen tank inspection we were talking about. So our team of advisors, here's the list. 2 of them have a combined experience of 50 years in the energy sector. So that's our business and our technology. We're Pike Robotics, and we make inspection of petrochemical storage tanks safer, less costly, and more accurate, helping reduce a large source of greenhouse gas emissions. So we appreciate your support in our mission of transforming inspection of oil and gas facilities through robotics. Thank you.
Thanks so much for your patience as the computer decided to restart twice. But over to the judges.
Thank you. And thanks, Connor and Frank. I like keeping pushing through with the technical difficulties. It's good. And then showing up your robotics here. So could you, maybe for the broader audience, let people know that how big you think this oil and gas opportunity is? And then in addition to that, for the robotics, like what are other inspection or kind of preventative maintenance that you can do for example, like in the renewable industry?
Sure. So that's a very big question. I'll bring up the slide right here. For the robot as a service industry, it's projected to be $142 billion. $60 billion is projected for the inspection, repair, and maintenance market, and $13 billion is coming for the inspection robots in hazardous locations. And so our bottom-up analysis of that floating roof seal inspection market fits in that $13 billion market that you see there. So as Frank alluded to earlier, I mean, you worked at Dow Chemical for a while, bringing innovative technologies into your plant. So, I mean,
Yeah, I mean, anywhere there's a hazardous environment, which is most of the facility, our robotic technology will be applicable for. With the modification of some simple sensors, we'd be able to inspect pressure vessels, piping, other various types of equipment, distillations columns, etc., within those facilities.
We're also starting to explore inspection of hydrogen tanks, other flammable environments. We can also move this robot to inspect wind turbines as well. So down the line, there's a lot of other use cases. We're going to execute on this beachhead market first.
Really great presentation. Thanks for powering through. I think I know the answer to this, but you talked a little bit about Ohio and how you could, change outcomes in places like that. Can you talk a little bit more about that and how far you are from this really long-term?
Yes, ma'am. So to answer your question about helping to prevent fires or any other kind of disasters like that, so these tanks, if they're not, the seals are not inspected to a level of accuracy and quality, then you get a lot of trapped vapors in that space between the two seals. And lightning strikes have occurred, and we can go and afterwards I can show you some case studies of that, of lightning striking the seal and causing a fire. And if it is not stopped by other protection methods, then it can spread to the rest of the tank, and you can have a big accident like that you see on the national news. So we're just focused on this right now, but I think more accurate inspections with robotics, because it makes the entire job safer and less costly. You can do them more frequently. So because of all these issues, they're not able to do them as frequently as they would like to, or as the EPA would like these companies to. Let me rephrase.
Just great presentation. I'll echo way to hang in there through the technical difficulties. What do you anticipate the cost to manufacture one of these robots, and then how much revenue per whatever, month, per day, per year do you make off of it?
So our business model is built off inspectors in the field, and so each person in their respective truck or Prius would be driving each of these sites and have one robot with them and a backup robot as well. Estimate it's going to cost about $35,000 to build one of these robots, and it'll last around 100 inspection missions before needing like a retrofit, and that will require a whole other $35,000 in input. However, we're looking at the LTV of 6 different tank terminal sites across our market, and looking at about a $1.7 million average for the lifetime value, and about a $300,000 customer acquisition cost for each of those. So in terms of revenue generated per robot, we actually got that feedback from the Baylor competition that we did well in last week. And so I haven't done those numbers yet, but it's definitely a figure that I want to get done. So.
I wanted to hear more about your technology stack. So can you speak to how you're perceiving the environment as well as how you're interpreting it and making meaning out of it?
Yes, ma'am. So there's our, I think that was the issue, the video. So we're navigating around the environment, and we're collecting visual data of that mechanical shoe seal, and we're looking at the gap. That gap is really critical. So if it's above 1/8 of an inch and a gap, then these vapors would be allowed to escape out and kind of cause havoc in terms of combustible vapors and in terms of spreading to lightning strike. So we also have an
So is that LiDAR you're using, or can you speak?
We have a LiDAR built into the camera as well. So it's kind of 2 parts, visual and LiDAR combined, and also ultrasonic sensor. It's a rangefinder as well, where we're allowed to get that data from the raw data and then put that through one of our machine learning algorithms, because a lot of these tanks are very different. So we want to get the data to the customers as quickly as possible, get the reports to them as quickly as possible. So we're going through the process of training our detection algorithm on a number of tanks so that we can deliver that report to them as quickly as possible. So.
Thank you.
Awesome. Thank you.
So I was bored the other day, and I tried to make a robot myself that would help to distribute herbs, but all it did was pass the time. Yeah, maybe? So our next team is going to be Carbon to Stone from Cornell University. We'll give the judges a moment to make a couple more notes, and then we'll welcome Cornell and Carbon to Stone to the stage. All right, welcome.
And we're with Carbon to Stone, an Ithaca-based startup that seeks to enhance and improve carbon mineralization through the use of a regenerative solvent.
As the demand for energy continues to increase, the need for transformative, sustainable carbon management solutions becomes even more evident. Carbon to Stone aims to utilize the power of solvent regeneration and the vast amount of alkaline industrial residue to transform conventional carbon mineralization processes and capture CO2 from air and flue gas. Let's look at some relevant stats regarding this issue. Iron and steel are vital materials for building infrastructure and technology. However, the amount of waste that is being generated by producing iron and steel is incredibly high. Carbon to Stone intends to utilize the vast amount of energy critical metals present in these residues. About 180 million tons per year of mine tailings, 360 million tons of ferrous slag, and a whopping 2.6 gigaton of CO2 is being emitted by the iron and steel industry on a yearly basis, often impacting marginalized communities. This highlights the need for transformative solutions to capture, convert, and store CO2 using the vast amount of residues from iron and steel making.
So we know that carbon emissions is definitely a global issue. We can see its true extent even just looking at New York State. In New York State, where I study, the iron and steel industry is responsible for nearly 650,000 metric tons of CO2 per year. Similarly, the aluminum industry is responsible for nearly 220,000. Our technology seeks to alleviate this issue by reducing greenhouse gas emissions from industries as such, and is in line with net zero targets set by New York State and beyond. Conventional CO2 capture and mineralization approaches are not environmentally or economically sustainable. Conventional approaches rely on an air or flue gas stream entering a CO2 absorption column at 25 to 40 degrees Celsius, emitting CO2 lean gas. The contents from this absorption column can then enter the regeneration column at 60 to 120 degrees Celsius, releasing high purity CO2 that can later be mineralized.
As some of us are aware, the process described by my colleague Elena is usually characterized by high temperatures and multiple unit operations, which lead to high cost. In numerical context, about $200 per ton of CO2 is required to capture CO2 from air, and a wider margin of between $50 and $300 is required to capture, to mineralize the CO2. Carbon to Stone aim to address some of these challenges by combining both the CCUS portion of this technology with the mineralization portion of this technology to create an efficient process that has a much more thermodynamically favorable pathway.
Combining carbon capture and mineralization into a single efficient process can help optimize and reduce costs in carbon management. We can see this with Carbon to Stone solution of two different applications of the same chemistry. In the case of flue gas and calcium or magnesium-bearing alkaline sources, such as slags, react in a gas-liquid solvent reactor. This reactor occurs at 50 to 75 degrees Celsius in the presence of a regenerated solvent, yielding calcium or magnesium carbonates and outputting CO2 lean gas. This process can be achieved at $35 to $55 per ton of CO2 capture, which is in line with current DOE targets for CO2 capture at less than $50 per ton for CO2 capture from flue gas.
In the case of direct air capture, air enters a liquid gas contactor at 25 to 50 degrees Celsius, which then removes CO2 lean gas and a CO2-loaded solvent. The CO2-loaded solvent is then contacted by calcium and magnesium sources to produce calcium and magnesium carbonate. Now that the CO2 has been removed from the CO2-loaded solvent, the solvent is regenerated back into the gas liquid contactor. This process can be completed at about $83 to $126 per ton of CO2 capture, which is in line with the DOE target for DAC of $150 to $200 per ton of CO2 capture from air. Our technology is highly competitive and has significant advantages over conventional traditional carbon mineralization pathways, including lower cost due to fewer unit operations, lower temperature, and a dual-purpose, highly regenerable solvent. Also, our process is characterized by lower reaction times.
Our process has also been shown to work with more heterogeneous materials. For example, in the case of ash materials with a similar composition to slag, we were able to successfully mineralize them to produce calcium and magnesium carbonates. In fact, 40 to 55% of this conversion can be attributed to the high levels of calcium oxide present in these materials. With our methods, we produce results with 4 to 5 more enhancement in carbon mineralization than through conventional means.
Our market possibilities are widely expansive, ranging from metal manufacturing companies such as Nucor and Novelis, to mining industries such as Stillwater, to energy companies such as Aramco or Chevron. In fact, we have the possibility of selling credits in the carbon marketplace. In fact, recently, Carbon to Stone got a $500,000 pre-purchasing agreement with Frontier Stripe Climate and Shopify. Just like one could pre-purchase a Tesla, Carbon to Stone obtained pre-purchasing carbon removal services from FSC and Shopify to demonstrating trust and confidence in our technology.
Some of our current industry partners include Nucor, America's largest steel recycler, and Novelis, the world's largest recycler of aluminum. We plan to work with these industry partners for pilot plant studies where we aim to capture 40 tons of CO2 per year.
In terms of competitive landscape, current carbon capture, storage, and utilization companies such as Rockfix, Climeworks, and Carbon Engineering focuses solely on the carbon mineralization and utilization aspect of this technology.
Sorry about this.
I think they just froze the main screen while they. Sorry for this again. Does anyone else have any very awkward morning jokes about energy that they could share while we wait?
I mean, we flew all the way from New York State. Then obviously, that's a lot of CO2 that needs to be captured by Carbon to Stone, hopefully.
Yeah. Any jokes we won't take for granted? Maybe? All right, try again.
Sorry about that, guys.
So, in terms of competitive landscape, just like I was saying earlier, current companies such as Climeworks and Rockfix focuses solely on the carbon storage and utilization aspect of this tech, whereas companies like Heirloom and Akron, formerly known as Carbon Minerals, focuses on the mineralization aspect. At Carbon to Stone, instead of dealing with this situation separately, we aim to combine both the carbon capture, storage, and utilization aspect and the mineralization aspect, thus diversifying our revenue stream.
In terms of revenue streams, our current two streams include carbonate-bearing aggregates at $14 to $20 per ton, as well as 45Q tax credits at $130 per ton for CO2 captured from air and $85 per ton for CO2 captured from flue gas. The benefit of having multiple revenue streams ensures our business ventures durability even as the tax credit landscape changes. Our process also avoids certain costs associated with conventional means of mineralization. For example, you don't have to deal with the cost of crushing and grinding rock, tipping fees, or the use of acid and bases. In the future, we hope to earn revenue through energy-critical metal recovery, as well as CO2 capture using industrial residues. In fact, we currently have 7 pilot patents and are in the process of filing another patent with Cornell University for this energy-critical metal recovery.
Here's a general timeline of this technology. Right now, we are in the process of achieving high-efficiency solvent regeneration and deploying DAC and our DAC and mineralization process via the plastic center incubator at Cornell. Hopefully, in the next year, we hope to activate Tier 2, which involves engaging our industrial partners, Nucor and Novelis, thereby establishing our pilot plant with the hope of capturing 40 tons of CO2 per year. Over the next couple of years, we plan to scale up commercially with the goal of capturing over 1,000 tons of CO2 per year.
Lastly, we'd like to thank our team, Akanksha, Shardo, and Akanksha, who couldn't be here, as well as our advisors, and then the various labs and offices that have supported us, including the DOE, Argonne, National Labs, NSF, and the Atkins Center at Cornell University. Thank you, and we'll take questions.
Thank you so much for the presentation. Could you elaborate on the carbonate that you recovered? Like, what are the potential use cases for that? Like, who you were able to sell them to?
We can totally elaborate on that. So the carbonate that we produce can be used as a building material, and we plan to work with different manufacturing companies that make cement to integrate it potentially into their formula for cement.
Yeah, That's correct. We could, there's a wide range of possibilities of selling these carbonates materials, including cement industry, just like Ehina intimated.
Yeah, so you might also want to add like a Blue Planet and Forterra, your competitors, because I think that's also something that they're looking at. Yeah.
So thank you for that advice.
Great job again. Technical difficulties. Really great job. I wanted to get clarification on your business model. Is it that you were proposing to construct a standalone facility, or is it something that is co-located with?
Yeah, it's co-located.
Co-located?
Yeah.
Okay. And then is there any type of agreement that you need? Who will own the technology? The company that is hosting the technology, or yourself?
We do own the technology.
You guys own it?
Yeah. So we just built this plant in these partners' sites.
Okay. Yeah. Last question. Sorry. Then, if that's the case, are you offering any type of operating agreements with your partner, or have you thought about this in the case that it affects their own production? Have you guys thought about anything like that? Thank you.
Yeah, that's a really good question. So, in terms of like co-locating, obviously there will be challenges with regards to trying to sync with the current production process in the facility. So right now, like in terms of incentive, these companies tend to generate a lot of like CO2, which is being emitted into the atmosphere. They have a problem, and we are offering a solution here. We're telling them, hey, we are going to retrofit your facility, build a standalone facility, a standalone reactor that basically just take your flue gas directly from your stack, and then remove the CO2 from the flue gas and produce these carbonates. They also have this vast amount of slag minerals which they just leave sitting. In most cases, they take it to landfill. Obviously, there's the cost of transportation that we save for them, shipping these materials to landfills. And also, we also prevent situations where we have certain metals like chromium, nickel, copper, all in these residues which could seep into the groundwater, affecting drinking water system of communities. So yeah, we've kind of like envisioned cases where our process could slow down production, but this is something that we aim to deliberate more on as we move towards the pilot phase of our technology.
One thing I wanted to add to that really briefly is that with slags there is a lot of profitable and important metal that's being wasted, and we hope to integrate energy critical metal recovery with our process. So for companies like Nautilus or like Newborn, that would be very beneficial for them, so they would want our technology in their facilities.
What's your efficiency of like removing CO2 from the flue gas?
So right now we are able to, it depends on the kind of solvent we're using, and it depends on like the scale, right? So right now we have been able to remove almost all of CO2 from flue gas, but with direct air capture it's a little bit tricky. Yeah, so we have like a range of between 80 to 95% removal of CO2 from flue gas, but we are still in the process of modifying our direct air capture facility.
Could you also talk about your waste product, kind of how you do the remediation and make sure that there's not like too much of the solvent and the toxicity getting into the environment?
So basically, there are like two stages to this. So the first stage. So there are two stages to this. So basically, our solvent is regenerable. So meaning that we get to reuse the solvent over and over. We've tested this in the lab and it's worked up to 10 cycles. So in terms of like waste product generated from this process, basically we do not generate any solid waste, because just like Elena earlier intimated, we do sell the carbonate aggregates. We hope to sell the carbonate aggregates to cement making industries. In terms of solvent regeneration, we just regenerate the solvent, and we are actually in the process of developing functionalized materials that actually that remove metal directly from the solutions. Yeah. thus making it like metal free basically.
One quick thing, the benefit of our solvent is that it's pretty environmentally benign when it's done after the process. And we work in the lab for optimizing it and ensuring that it's truly regenerable. So part of that is like working with different filtration techniques, like centrifuging your product or using a general filter.
Thank you so much.
Yeah, thank you.
All right, thank you everyone for listening to all those presentations. We're going to take a short break and come back 5 minutes after the hour. So a little bit later than what we planned. We'll look forward to seeing you in about 10 more minutes. Thanks everyone. Thank you, everyone, and welcome back from a very quick break. The next one will be longer and it will have food, so that will be nice as well. But without further ado, to keep us as close to schedule as we can, I'm excited to introduce Rockfix from Stanford University and Harvard University. Welcome.
Ready to start?
Go for it.
Hello everyone, I'm Gus from Stanford University.
And I'm Melissa from Harvard University.
And we are Rockfix, unlocking permanent carbon storage in mine waste. Has anyone been to Salt Lake City? One person, a couple, okay, keep that in mind. Now, we have a vision for carbon sequestration. Imagine Earth's natural carbon sink, which puts carbon into rocks over millions of years through the geologic process, accelerated at scale using the mining industry. We could store 1.6 billion tons of CO2 in copper mine waste. And in addition, we could create additional US critical metal extraction and create jobs for those rural mining communities across the country and the world. So for those of you who have been to Salt Lake City and those who will go, I recommend you do. When you land, look left, right as you're approaching, and you will see a beautiful sight. This copper mine. It really is pretty. Now, the mining industry is the foundation for the green energy transition. Without mining, we can't do it. I should know, I was, before Stanford, chief engineer of a copper mine in the US.
and I spent 7 years in the copper mining industry across the world. So let me tell you how it works. The first step is you make a big hole. You dig all that stuff up and you put it in trucks, you process it at a processing center called a mill. For copper, the concentration of copper is about 1%. That's what they pull out. That means that 99% of that material is waste. And it stays there forever in waste dumps and tailings facilities. We think there's value there. Now, who runs this massive operation? Our target customer, the general manager. He wakes up at 4 a.m. every morning, gets in his pickup truck, drives to his office, which is right there, and he's worried about mine profitability, stabilizing the waste dumps and the mine, having good community relations, and his CEO just called. He needs to figure out how to decarbonize the mine. And good news for him, he's got a corporate team now of decarbonization experts. So what is the mining industry doing to decarbonize right now? Well, the industry is at an inflection point, but it's risk averse. So they are targeting easy to abate emissions through things like switching their power sources to renewables through PPAs, electrifying the easy to electrify equipment. But there's this mindset of we want to be fast followers. That leads us to an industry that doesn't want the costs of decarbonization and doesn't want the disruption. And there's no good technologies that meet their zero goals on time and on budget. Well, that's where we come in. We are accelerating this reaction right here, using calcium and magnesium to store CO2 in mineral form on mine tailings forever. We're doing this through a batch process reactor that will carbonate the material and extract critical metals in the process. It will sit in the mine processing facility without disrupting their flow sheet and provide revenue to that mine. Let me walk you through how it works. We take the waste coming out of that mine, we leach it. Out of that leachate, we get calcium, magnesium that we carbonate and we reincorporate with the rest of the tailings. We also get metals like cobalt, copper, and nickel that we can sell separately. And then we regenerate all the reagents in the back end to make sure that this is scalable and cost effective. Now, like any carbon tech, energy is a huge factor. So that's also for us because we have a temperature swing process. We've conducted a life cycle assessment to figure out how much energy this takes and how we can reduce that. Our process requires 24 megawatts to operate using real mine data from a mid-sized US copper mine. Heating and cooling processes require energy. We can capture some of that energy. There's heated reactions, and because we're using less than 80 degrees Celsius heat, we can use heat pumps to supplement that. The real innovation here is going to be things that levers we can pull to reduce the temperature swing that we require, improve the heat recovery, and find supplemental sources of thermal energy for our process.
Thank you guys. So how exactly are we going to turn this into a real business? So we have designed a 2-year roadmap with clear technical and commercial milestones, which we are well positioned to accomplish. Since Bill Gates started funding our R&D in the lab last year, we have been conducting benchtop testing, moving toward a prototype by the end of the year and on-site pilot within 2 years. On the commercial side, our team was founded based on customer discovery. And as we started learning more and more from a wide array of stakeholders, we have signed early partnerships with mines, moving toward advanced carbon commitments, as well as corporate letters of intent and long-term commercial agreements. We are also very much aware that we are just one company in a growing carbon tech ecosystem, and we are keen to do our part in developing the policy standards in order to accelerate the rock weathering sector. Okay, and to get even more granular, let's talk about our business plan. In one line, we're revenue sharing with the mines. Our first pilot will target $40 million in revenue per plant, starting with a low but positive profit margin that will grow significantly as we reach commercial scale. In particular, if you look at our revenue breakdown in that pie chart, we have 4 sources of value. That is carbon credit sales, 45Q tax credits, metal recovery sales, and a tailing stabilization fee paid by the mine. In the long run, I want to call out the yellow slice. This estimate only estimates cobalt recovery and doesn't account for other metals, which will make that part of the slice grow the most over time. Now, our first pilot plant expects to sequester 160,000 tons of CO2 per year
and our commercial plant will grow to 1 million tons of CO2 per year, which is pretty big. And when we're looking at this space of who else is mineralizing CO2, some of them are in this room, as you just heard from, the two criteria we ask you to consider is scale and measurability. In particular, when we think about scale, I urge you to look at in situ and underground solutions. Otherwise, we were looking at mine tailings for high scale. And when we look at us and our competitors, our greatest difference really lies in our focus on copper. Why copper? Copper is the holy grail for us. So for all the folks looking at the numbers, please look at row 2. Traditionally, a lot of our peers focused on nickel, simply because it has the highest reactivity per kilogram of CO2. However, if you're actually looking at the tons of tailings all around the world, it's a different story. How different? There is 60 times more copper tailings in the world than nickel. Both are very important metals, but this ultimately translates to a 20x multiple on how much CO2 we can sequester through the Rockfix approach. In addition, we can integrate metal recovery, which is key for US DOE objectives, because we're developing a unique thermochemical approach. So our competitive advantage all comes back to impact. And impact is what brought our team together in the first place. I love working with this team. We're a group of diverse, qualified, and experienced individuals with expertise from left to right in mining, right here, business operations and finance, as well as chemistry, geology, strategy, and chemical engineering. But that's not it. We've worked together for over a year building traction and raising over $500,000 from funders such as Breakthrough Energy, SOSV, and NYSERDA in order to conduct our independent lab work of benchtop testing in response to over 150 customer interviews. We've learned a lot from them, and we have started signing partnerships with 4 mines out of our target 15. We were recently, just last week, named a finalist for the Harvard Presidential Innovation Award out of 300 plus applicants. And I wanted to show you some pictures of our lab in California, and Gus and I just 2 weeks ago had the extraordinary opportunity to present our work at ARPA-E. So that's not enough. We have to look forward and we have to keep moving. And to do that, your help is critical. In particular, we invite partnerships with copper mines and universities focused on technical expertise as well as data. We're also looking to hire 3 full-time employees who are rock stars, who are geochemists, process engineers, and lab technicians. And last but not least, please email team@rockfix.co to help us raise our pre-seed round as we all become full-time employees as of last week, and for me in 2 months. Thank you. So to conclude, we are Rockfix. We are unlocking permanent carbon storage in mine waste and boosting US critical metals. And now I invite any and all questions.
But here we go. My questions are, you talked about, well, actually first, I don't know if you mentioned this, but where does the waste go right now?
That's a great question. Right now, all the waste generated in mines across the world gets stored forever in a big pile. Whether it's a tailings facility or a waste storage facility, those are permitted, often lined facilities that have to be monitored for decades after the mine closes. And they're going to stay there forever.
Okay, thanks. But actually, my real question was, you talked a lot about these partnerships, and it sounds like you have agreements started. Can you talk a little bit more about what those entail and what you all have kind of been able to flesh out so far?
Yeah, sure. So as Gus had described, the mining industry is fairly risk averse, and even the way we're engaging with them has been a learning process. So there's really, I would call it 3 channels that we have been working with. For the large size producers, they actually have started within the last 12 months building out a corporate VC arm, some of them full of miners, some full of non-miners, to find new technologies for the firm. A second leg would be the picture of that woman. She's usually, or he is in the corporate exec team, previously VP of finance, and now they're also in charge of sustainability. They're very excited about finding solutions that can work and fit their 5 to 7 year scoping plan for the next permit, for the next mine, or to extend the life of an existing one. The third piece is the guy, we fondly call him Melvin. He's the GM of individual mine sites under the mother company. And although he does not make the decision in terms of investing or starting an NDA or an engagement contract, we need him. We're very fond of him because he's the implementation guy. And in particular, as we visited these sites over the past half year, we learn about their kids, we learn about their lives, and it's really important to us that we're including him as a part of this futuristic solution, as he's in charge of electrifying equipment and figuring out what else does corporate want me to do on the ground.
Actually, can I just follow up one more thing with that? So these are really strong relationships that you have right now, but not necessarily agreements or commitments, which I think are the relationships are very, very important, so not to say.
We do have legal agreements in place.
Okay, perfect, thank you.
What is the origin of the technology and what's been demonstrated so far? What have you guys been able to show?
Yeah, so every part of our technology, there's scientific published literature about this, whether it's leaching, whether it's sequestering CO2 through solutions, regeneration of acid. So all of these steps have been proven out before. However, they haven't been put together in this process. So what we're doing is putting all these together. In the lab, we're working on the regeneration stage and the leaching stage right now, and we still have to do in the lab ourselves for due diligence, all the other parts of extracting metal and carbonating the CO2. So those are the parts that we're working on. But the big thing here, I said, kind of the innovation is going to be putting everything together and making it all work, because each one of these pieces has worked for different purposes, but never for this purpose.
Thank you so much. Really good presentation and a lot of details over there. My first question is around your revenue sharing model. So you have like carbon credits and 45Q. How much is that kind of in terms of your percentage of your total revenue? And the areas that I'm coming from is the tax policies are good, but they're also sometimes temporary, right? So what's your long-term goal?
Yeah, thank you for the question. So we actually, I'll be honest, we started out with a full business model based on regulatory credits, and a lot of investors did not like that. Which is understandable. And so we're early enough, we completely own the tech, we're not affiliated with any university, and we pivoted to really focus on the fact that we can extract the secondary metals. And frankly, that's the incentive that aligns us most tightly with the miners themselves. So in the pie chart I just showed, we have a 2/3 split of various types of credits. The 45Q is more upfront CapEx, and the other one is more of an operating kind of cost reduction. But we do want to expand the other third of the pie of the tailing stabilization fee and the metal recovery to be the majority. And I'll tell you, we've used a very, very conservative number for the tailings fee of 1 cent per ton. In the real world, they're paying $2 to $4 per ton of removal. So we're giving them a big discount at the start of the tech.
Just to follow on that, so how did you come by this revenue share business model? Is this standard in the industry, or is it something that you all have innovated?
This is a very standard thing in the industry. Royalty models, streams. If mining companies know how to pull stuff out of the ground, they also know how to divide it into many parts and share the value. This is really, really common in the industry.
What would you say about your kind of top 3 hurdles for you to get to the 1.6 gigaton CO2 abatement?
Yeah, I can take a crack. I would label it under tech, commercial, and talent. So on the tech, as we mentioned over breakfast, we're at TRL 3 to 4. It is a competitive space, and we really want to get our reaction rate and energy consumption to a place that our mining partners are excited about for the pilot. On the commercial side, this is a high capital cost project, and we are aware that we need to partner with patient capital as we de-risk and sign these partnerships with the mines. I think they appreciate that we come to them, whether it's their corporate headquarters or their site, and really get to know them. Talent, we have Gus. I think I've met very few teams, and he's one of the reasons I wanted to work on this, who have worked in mining. And I think overall the team's values are aligned. But again, like we're thinking about hiring, I've started interviewing, and it's just really humbling to see who's out there who's interested in working on this.
Thanks for your questions. Let's make mining part of the solution.
Thanks so much. give everything to Jay. All right, so thank you everyone. It's good to see you, and thank you to the team. So I do have one joke about geologists, since we talked a little bit about mining, and I have a question. Why do geologists tell old jokes? Because they dig them out. So our next team is going to be the University of Louisville, Terrazzo Soy. So we'll bring them up on stage now. But welcome.
Hey everyone, my name is Sal.
And my name is Pawan.
We are PhD candidate at the University of Louisville. And me and my colleague Bhavan started the soybean resin project for construction application. Our goal and focus is to replace petroleum-based resin with a more renewable and sustainable resin extracted from locally harvested agricultural products here in the US for the construction industry. Let me start by defining the real problem that our technology and our business is trying to resolve. The US construction industry heavily relies on petroleum-based resin. Petroleum-based resin have a very high carbon footprint, and this is not all. It also relies on a broken and non-reliable global supply chain, all the way from raw materials to local US construction sites. And just for the recent event during the last COVID-19 pandemic, the COVID-19 pandemic had showed how broken and unreliable that supply chain system is, where the petroleum resin supply chain showed its inefficiency, where it led to reduces in supplies and increase in prices. Our solution is to replace the petroleum-based resin with a more renewable and sustainable resins that's extracted from locally harvested soybean agricultural products. Soybean resin has lower carbon footprint compared to petroleum resin, and also due to its organic nature, and this is not all, it has lower carbon footprint because of its more environmental friendly supply chain, all the way from soybean farms in the East Coast all the way to the US construction site on the West Coast. And the best part is yet to come. So the soybean is the second, US is the second producer of soybean agricultural products, which means that relying on soybean for producing soybean resin is highly reliable. And this is not the best part yet. The second best part is that soybean plants act as soybean sinks. So we're not only offsetting the carbon footprint by replacing petroleum-based resin with a soybean resin, we're actually helping in actively and passively reducing the carbon footprints, since soybean plants act as carbon sinks. The Terrazzo tile is a great example for the US construction, where it heavily relies on petroleum resin. The US is a key player in the Terrazzo, architectural and engineered Terrazzo tiles, and also a key player in the soybean agricultural products. Our technology is not only limited to substituting the petroleum-based resin with a soy-based resin. Actually, we're capable of even creating geometries that mimics the shape and the performance of marble chips, which is traditionally has been utilized in the traditional petroleum-based resin. Actually, we're even successful in creating a Terrazzo tile that was entirely made out of soybean resin.
All right, let's have a quick look at the, sorry, let's go back. Okay, let's have a quick look at the market that we are addressing and we would like to obtain. Right now, worldwide, the epoxy resins that go into construction have a market of about $30 billion. And just in the US alone, it's a $10 billion market. Even if we are focused just on the flooring industry, we are looking into obtaining a market of at least $500 million. On top of that, this also looks promising looking at the CAGR values for Terrazzo market worldwide and also in the US. We see our product go into commercial construction industries. These are places you might have visited at some point in your life, educational institutions, grocery stores, transportation infrastructure. These look beautiful with the current Terrazzo tiles on them, but if you really look underneath, you will see that more than 40% of each of these tiles has embodied carbon in it. On top of that, what not a lot of people talk about is the terrible heat retention properties. They get really cold when during winters or when the temperatures are low. And finally, what we also started realizing is the variability is very high depending on where you get your materials from, and there is not a consistent standard or quality control on the current epoxy resins that you are using. And that is what we were trying to change, and how we are set up is we are a B2B company where we are serving local tile manufacturers to diversify their product line and offer their customers a greener alternative. Not only does this help the environment, but it also helps our customers achieve LEED certification for their projects and also obtain carbon credits. We are highly collaborative with local businesses, and we would also like to set up R&D facilities and quality analysis services to ensure that our product does not vary much from one place to another within the country. The best part about this is it costs much lower, not just in the material, but also for labor and logistics. The way we see it, we are not essentially competing with the Terrazzo market. It is a huge market, but we are complementing the market with a greener alternative by providing the customer's choice to go green according to where they want it. A quick look at the cost analysis, you will see that local manufacturers buy Terrazzo resins, petroleum-based, at about $25 to $30 per gallon, whereas our product, which is completely bio-based, costs as less as $10 per gallon. Now, to put that into perspective, we were working with a local tile manufacturing company, and they consume about 25,000 gallons of resin every year, costing them $700,000. And even with a 10% addition of our bio-based resin, it saves them $50,000. And on top of that, we are already working at a profit margin on how much it takes for us to make this versus how much we sell it for. And I would look at it as a win-win situation. We have been working on this technology for more than a couple of years now, and we were fortunate enough to raise a little bit of funding to get the R&D started through early adapters and early customers, and also some award money. We are currently seeking $100,000 seed funding to ramp up R&D and also scale up production. And we are looking at getting into a positive cash flow by early 2025, where we will be relying on royalties and also sales. Why you should really care about this is because 23% of the global CO2 emissions comes from just 3 materials, and all of them are used in the construction industry. And this is not gonna get better anytime soon. And how you tackle embodied carbon is much different from how you tackle operational carbon emissions. And this is the time to act if we want to head towards achieving net zero emissions by 2040. To have a quick outlook on the environmental impact, we are looking to potentially reduce at least 10,000 tons of CO2 per year. That is a very modest number, considering we are impacting only 0.5% of the total CO2 that the construction industry produces every year. We give importance to creating a positive impact in the society as well. We work with local businesses, minority businesses, women-owned businesses, and small and medium enterprises. And we are looking at creating job opportunities, not just in the engineering sector, but also in different sectors across the industry.
Thank you, Bhavan. Before we finish up, here's a quick summary of our technology. Soybean resin is made by epoxidizing soybean oil, which is extracted from locally harvested soybean agriculture. The applications for the soybean resin is endless. As me and my colleague Bhavan, we have showed you the Terrazzo tiles made entirely from soybean resin, and also some 3D printing and advanced manufacturing with soybean resin for the Terrazzo tile industry. We're also currently working on creating geometries that mimics the shape and the performance of construction lumber by utilizing soybean resin, as we can see from the top picture on the slide for construction alternatives. At the end, here's a quick look at our team. Myself, Sal, and my colleague Bhavan are the founders for this project. We have academic collaborators from the University of Louisville, and of course we could not have done it without our industry collaborators, who most of them comes from small business industry and also minority-owned business companies that works in the construction industry, like Venosa and bio products. And actually, in fact, last week we got also approached by another minority business-owned company through our relationship with the Minority Business Development Agency through the Department of Commerce, who were interested in utilizing our technology. Toward the end, I would like to thank everyone, and I would like to mention that we all could be standing on a greener ground, and it does not need to be grass. Thank you.
Can you talk a little bit about other potential construction applications for these thermoset resins? I'm not familiar with where else they're used.
Yeah, our main focus for now is the terrazzo tile industry, but currently we are working on making construction materials such as lumber, where if I go a little bit backward, construction lumbers have specific performance and shapes, and what we're doing is through the utilization of bio materials such as soybean materials and also advanced manufacturing such as 3D printing, we're capable of creating geometries and structures that mimics the performance and the shape of lumber, which is our next goal.
Thank you so much. Sorry I missed your pitch, but I actually watched your 90 seconds pitch and read your deck. So one question is around the food source competition, because you're using soybean versus maybe other are using like a food waste or like recycled material. So how are you going to tackle that, like maybe through efficiency or other angle?
Yep. So that is a question we often get in terms of how do you balance out the consumption of what is produced and what is sent to the current market, and can we take a share of that? Basically, what we don't realize is this epoxidized soybean oils or any kind of soybean oils go into a lot of other industries as well, not just the food industry. For example, a lot of polymers use them as plasticizers, or some of our sports shoe soles also come from that. And another thing we also started looking into is how big the soy cultivation is in the US, and are we over exploiting that, if I can say that, or do we have enough resources to cultivate more and provide more avenues? And at this point of time, in fact, we are able to cultivate more and provide more avenues, but with the kind of market we are targeting, we can not only use the resins and the oils, but also the waste from these farms that go into landfills to like I said, one of the potential downside of the current terrazzo resins is the heat retention properties, which are really bad. Soy fibers and stuff like that, we have already made filaments and use 3D printing to develop different applications for that as well.
And I would also like to add to this, like my colleague mentioned, as an example, the soybean husks are what considered, the trash or the landfill of the soybean agriculture product. We were capable of extracting fibers from the soybean husks and implementing in materials to create the construction parts.
Maybe if I can ask a follow-up question. So you have demonstrated that the hardness is good compared to other materials. Could you also talk about kind of the durability, kind of abrasiveness test? Yeah.
Yeah, sure, definitely. So yes, we have done compared the soy resin and the soy coating compared with the conventional traditional petroleum-based resin and petroleum-based coating through different kind of chemical testing. As an example, Lysol is traditionally and most commonly used cleaning additives for surfaces. Both of them have showed similar results. In fact, in some areas, we were even capable of getting better hardness and also softness. So since we are in full control of creating the coating materials, we can create coating materials for the terrazzo tile based on the application. If it needs to be harder, we can increase the hardness. If it needs to be softer, if it's going to be implemented in sport fields. It might need to be software for safety of the players. So all of that has been tested. And actually, we have presented a specific, we presented at the conference of the American Coding Show last year in Indianapolis. We were only focusing on the coding with soybean oil.
In addition to that, there are, like I mentioned, there are not a lot of standards that people follow in the manufacturing industry of terrazzo tiles right now, but there are certain standards that really determine the quality or the structural stability of the tiles. We have performed things like scratch testing. It's a fun test. Take a knife and cut it and according to a specific method, and you see how many of those peel off and everything. We've stood on top of these tiles. I'll not do that now, but we've jumped on them. They sustain. And sometimes they don't. You don't not even feel the difference between a real terrazzo and whether it's made from petroleum-based or bio-based resin. So.
Thank you so much. Go ahead, Jackie. All right, thank you so much. So our next team is going to be low temperature libs from the University of California, San Diego. So they're getting set right now. We'll give the judges a moment to take some notes. And I don't really have any good jokes about soybeans, but I do know that an ideal name for someone who might work with that terrazzo material might be Tyler. That's all I know. With that, it looks like they're just about ready, and then we will introduce one side, and we'll go back. Low temperature libs from the University of California, San Diego. Welcome.
Hi everyone, we're Low Temp Libs, and today we will be presenting a new direct recycling technology for lithium-ion batteries called Low Temperature Hydrothermal Synthesis, LTHR for short. And this is our team from UC San Diego, with me, Pahan, Pivan, Kelvin, and Harrison. And here are our advisors, with Dr. Lee, Professor Chen, and Professor Jokers. Currently, Dr. Lee and Professor Chen are leading the development of this technology in the UCSD lab. And here are our advisors from the Nanoengineering Society at UCSD. The current information is from the DOE's National Lab IP licensing portal. This current method is under filing for patent disclosure under UCSD, and the UCSD lab is currently partnered with Argonne National Lab. Our innovation stands out from traditional methods, as we are capable of fully regenerating the cathode of the battery to the same level as new and pristine materials. Also, our method also improves upon direct recycling by utilizing green additives, which makes our process be able to run at a low temperature and a low pressure, which significantly decreases energy consumption, which also makes our process safer and easily scalable. Another important fact is that our process is capable of recovering large amounts of lithium compared to other methods. Traditional methods mainly focus on recovering cobalt. However, the EV industry is currently trying to transition away from that. And here's a quick rundown of our recycling process. So first, spent batteries will be shredded into small pieces. Then the cathode powder would be physically separated from the black mass. Then apart from direct recycling, we will introduce green additives into a lithium solution. After that, we will get the cathode powder and then mix it with the lithium solution and place it inside a reactor, where regeneration would occur. After that, the cathode powder will be dried and shortly annealed, resulting in a regenerated cathode powder. And so what is exactly going on inside the battery? Well, inside lithium-ion batteries, the function of the cathode is to store and release energy by allowing lithium ion to move in and out of the cathode. However, over time, the battery will degrade, leading to lithium deficiencies. This will cause the lithium ions to slow down and will degrade the battery, resulting in defects. This is where green additives come into play. The green additives would help lithium ions move easily within the cathode crystalline structure. Due to this, the process will require less energy, allowing us to run the hydrothermal process at a low temperature. Also, if you can see right here, this is a regenerated LFP battery. LFPs are lithium iron phosphate batteries, and they work really well with our process. And so, our innovation has proved to be immensely improved upon other methods, as we observed through the Everbot model and hydrometallurgy, China's main method of recycling batteries apparently uses 15 times the energy that our process utilizes. And not only that, but our process only creates a fourth of the greenhouse gas emissions that other processes create. Our process is making great strides towards a green, sustainable, and profitable future.
Yeah, so this is our projected growth in LIBs in the next 10 years. As you can see, it's a very exponential, large growth. In the year 2030, which is in 10 years, you can see it's about 120 billion in our market. And that growth in lithium-ion batteries reflects with the lithium-ion battery recycling market as well. So in 10 years, in 2030, it's about 40 billion, as compared to now, 2023, it's about 8 to 9 billion. Now, more traditional or current kind of processes use cobalt batteries, and cobalt is, cobalt batteries, as the name suggests, uses cobalt, and cobalt is a very unsustainable material, as well as lithium, and that keeps mining our Earth's limited cobalt supply. That's why currently many companies are transitioning to LFP batteries, which relies less on cobalt, and there's 3 points that I want to emphasize on this transition. Number 1 is that it's safer. Number 2 is that it's cheaper. And number 3 is that it outputs the same performance as cobalt batteries. And one incident I want to highlight that shows these 3 points is that recently GM had to recall all their vehicles, 2017 onwards, that were made because they were, number 1, catching on fire, and number 2, it cost them around $1.8 billion in costs. So these 2 points highlights 2 of the 3 points here. So these big companies, Tesla, Rivian, Ford, and Volkswagen, are all transitioning into LFP batteries.
All right, so who's our competitors? Currently, the LFP manufacturer is actually from China. They take around 80% of the manufacturing by 2030s. So in order to do that, China has a cheaper price, they have a cheaper labor, and they control almost the raw material sources. It takes about 20% of marketing, the shippings from China to here. It also increased our target price. So in order to prevent that, let's give a short look about the economy from raw materials to us. So essentially from the raw materials, a Chinese battery manufacturer will manufacture the battery, and you ship to us, to commercial or residential users. And finally, after the battery is retired, you ship it back to the Chinese battery recycling center again. So it takes around two types of shippings. And with us, with our technique, we can do all this inside of the United States, generate a really good circular economies inside the United States. And starting from the spent cells, our technique can recover around 98% of the raw materials back to the manufacturers, and we can give it to the cathode manufacturer, and it comes to the second life to reuse the batteries, and finally recycling back to us. With that, we start playing a role in the energy transitions. We will create more job opportunities since we are involving separations or doing recycling plants. And last, pollutions. And here's our market. Our TAM is around $25 billion. Our SAM is around $2.5 billion. And our SOM is around 625 millions at 2028. And here's our competitor in the United States. There wasn't really a really large capacity recycling plant in the United States. Most of them are planted, but it's not built up yet. So we have a lot of retiring EVs in 5 years, but also at the same time we will have easy to just make the market in the United States.
Yes, LFP cathodes are one of the cheapest batteries in the market.
but that also makes it the hardest to recycle profitably. Using China's traditional method of pyro and hydrometallurgy, we see that through the Everband model of a 10,000-ton facility, that they actually make millions in net losses. However, because of our low cost and high recovery, we actually profit much more, 47 million in fact. Our transitioning to LFP batteries also has a lot of potential impact. It drastically decreases our need to depend on cobalt, which is sourced through the inhuman mining in the Republic of Congo, which also creates a lot of greenhouse gases. And our low temperature, pressure, and safe chemicals also reduces the millions of dollars lost in property damage and chemical spills. LFPs also increase grid resiliency from how safe they are. Our plan to do this is securing enough funding to start a pilot plant and continue optimizing the technology and find our beachhead customers, which service small enough that we can support them with a small facility. In 2024, we will launch our pilot facility and use the results to conduct customer discovery for larger companies and seek more investors. And because of our lower costs, we will be able to scale up across California much easily and also continue that momentum across the country. That is all, and thank you for listening.
Thank you so much for the presentation, and pretty impressed on like how much you have done. I know that most of you are undergrads. So first question is around your kind of capacity retention. Could you talk a little bit about kind of how much percentage that you can like get retained, and then also the condition that you're doing that for?
Wait, sorry, could you repeat that again real fast?
Yeah, so are you able to like retain typically like in this space, like LFP would be like around 80 to 90% retention for the capacity under like 400 cycles?
Oh, so the life level doesn't really matter. Even if it's 80%, 50, 20%, we experiment on all types of levels, and we manage to make it all go back to 100% performance.
And are you have you done that in the lab scale?
Yeah,
or?
we actually done it in the lab before, and it has been experimented on our research paper.
Okay, thank you. Yeah.
So just to make sure I understand, is your goal as a business is to build recycling plants and be a recycler, or are you considering licensing the technology to other recyclers?
Our principal plan right now is to build a recycling plant because there are just not that many across the U.S., but we are also very open to licensing these to larger companies to support a green future.
I saw you all talked about some of the EV car manufacturers. Who is your target market for this in terms of how would you collect batteries to get to your recycling plant?
Well, the thing is that because batteries are used so much that a lot of batteries are even disposed of, and disposal actually costs more than shipping it to us to be able to recycle. So we are able to service a very large market from Tesla, GM, and Ford. We can do many battery types, so it really doesn't have much of a target.
What would you say is your secret sauce? Is that the process or is the green additives? Yeah, could you elaborate on that?
So yeah, the secret sauce is basically the green additives we add. The green additives would allow the lithium ions to move easily within the cathode structure. If you want, I can explain this a little bit more in depth. So basically, when the battery degrades, there are also metal atoms in there too. And so they go from Fe2+ to Fe3+. So when that happens, they're a bit more positively charged. And as you know, like charges usually repel from each other. So then, when green additives are added, they allow the Fe3+ to go back to Fe2. And because Fe2+ is less positively charged, the lithium ions would be easily allowed to move through. So usually, when they're trying to move through without the green additives, it would be kind of like this, a little bit hard. but when the green additives are added, it'll allow it to move smoothly more through. And then less energy would be how to be utilized, so we can use a low temperature.
So how are you going to compete with other companies that have different or better green additive?
All right. So that part we used to like optimizing. Now currently we have like ordering like a 20 kilograms reactors, but we still have to optimizing our temperature and pressures, because like if you want to go down to the lower pressures, it gives you lower cost, but the duration operation time will be longer. And however, if you want to raise up, it might like it's giving you the same product, but like it just depends on the processing time, how long it's gonna take. Currently take around like 3-4 hours for like 2 kilograms reactors, and we're still working on that.
All right, so our next team before we break for a brief lunch is going to be direct recycling of cathode manufacturing waste from The Ohio State University and the University of Akron. So Jackie's getting them set. I see judges making a couple notes. And so as we think about low temperatures or temperatures in general, I was thinking about what never changes temperature no matter how hot or cold it is. A right angle. It's always 90 degrees. There we go. Someone laughed. The day goes on, I get fewer and fewer laughs. But I'm very excited to welcome The Ohio State University and the University of Akron.
Yes, so we are the University of Akron, and we are presenting our direct recycling of battery manufacturing waste. Now, I'm actually really happy that we're going now because you've got a lot of the groundwork done for us already and analyzing the battery recycling market. Next slide, please. Yes, this is our team. I'm Dominic Frazone. I'm a first-year PhD student at the University of Akron. I've been studying this for about 3 years now, and I'm happy to be joined here by Spencer Fraze and John DePaulo, who are 2 undergraduate students also working on this for their senior design. Sai, unfortunately, was not able to join us. He's a student at the University of Akron Law School, and he did a lot of the work for the IP and patenting that we've done with this technology. Next slide. So this is our recycling machine. It implements an organic solvent to directly recycle cathode manufacturing scrap, which is the nuance of our business plan. We are not attempting to recycle old end-of-life batteries. Cathode manufacturing scrap is going to be the largest source of recycling input in the United States up until and through 2030. So the way that this machine works is cathode electrode scrap is input into the shredder, and a mixer mixes the organic solvent with the shredded electrode and is filtered to produce current collectors, aluminum foil current collectors, and cathode active material. So with that, to talk about the business model, I'll hand it off to Spencer.
Thank you, Dom. Yes, so right now the world is changing at a rapid rate. Currently, battery manufacturers are being incentivized to produce more volume, allowing the U.S. to be less reliant on fossil fuels. EVs and batteries will play a huge role in the transition to green energy. To support this growth, several battery manufacturers will be opening up battery plants from now through 2030. In the next 6 years, manufacturing capacity will increase by 10 times, with 13 new battery plants to be opened by 2025. And as you can see on that map, there is locations of different battery plants in the U.S. Efforts are also being made to recycle battery manufacturing waste, as Dom was just talking about. This will be the primary source of recyclable material for the next decade. So the current recycling process goes as follows. The battery manufacturer ships or sells their manufacturing waste to a place in the U.S. where it's chopped into tiny little pieces. Then it's shipped to Europe, where hydrometallurgy and pyrometallurgy techniques will be used to decompose this manufacturing waste. Then it's shipped to China, where this manufacturing waste will be refined again. Then it's shipped back to Europe, where it will be decided where it will be sent to. And then finally, it will make it back to the battery manufacturer. This logistically convoluted process produces an unacceptable amount of greenhouse gases during its 17,000-mile journey. Along with this, 9 times out of 10, this material does not make it back to the original battery manufacturer. Hydrometallurgy and pyrometallurgy are also use toxic solvents and acids that are extremely hazardous for the environment. Along with this material in the manufacturing waste is perfectly refined and it is now broken down during this recycling process, needing to be refined again. And along with this, it increases our foreign dependency due to the fact that most of these refining plants are in China. I talked about some of the new plants opening up. While these plants will help to support the growing EV market, they are incredibly inefficient at the start of production. In the first year, they were expected to, in year one, they had 37% of their max yield rate. In year two, 75%, and year three, 80%. With this comes quite a bit of waste due to the fact, due to the low yield of batteries.
So in this use case, we talked to engineers from Tesla and Panasonic. This is a case study on their factory in Nevada. This is the oldest cell manufacturer in the world and the best engineering firm in the world, and they were only capable of getting a 37% yield rate. We completed the NSF I-Core program and validated the data that suggests that it may be even more than a 60% waste for an individual manufacturer, specifically new manufacturers that are just getting into the business.
Yes, so we've talked a lot about problems. Let's talk about solutions. So we've worked diligently to produce a solution that addresses all the problems I talked about before, and this is direct recycling. So direct recycling is a method of recycling that keeps all the cathode scrap within the manufacturer's facility. Instead of a 17,000-mile journey, all of this refining and recycling will be done internally. This drastically simplifies the logistical and carbon footprint of the current process due to the fact there's no need to send this material to China or Europe. It all stays within the plant.
To enable direct recycling in the U.S., we developed a machine that is low cost, compact, modular, and environmentally friendly. This patent-pending machine will be fully automated and can accept waste directly from the plant, which is then upcycled using an environmentally friendly solvent. This means that the battery manufacturer will receive its waste in its original state, and this allows them to have more control over their supply chain. The size and throughput of the machine has been designed to be highly scalable, with any combination of components replaceable based on facility needs. With this direct recycling technology, all the current inefficiencies of current recycling methods can be addressed and eliminated. To implement our technology into battery manufacturing plants around the United States, we proposed a three-step plan. First, acquiring agreements from partners to obtain the proper amount of waste needed to test our machines. The main target partners are battery manufacturing companies such as GM, Rivian, and iMany. Currently, the team has established a collaborative agreement with GM, who is a big player in the battery manufacturing industry in the United States. Second step is tech implementation. Currently, a prototype is being built that will allow us to test the construction of the machine and adjust where necessary. After technology demonstrations, the team will look to install our machines into battery manufacturing facilities around the U.S. The third and final step is customer agreements. Based off our initial customer discovery, it shows that battery manufacturers are very interested in our patent-pending machine to not only help them reduce battery manufacturing costs, but to supplement current production capacity. With this initial interest in our hardware-as-a-service business model, the team will look to keep growing relationships with battery manufacturers around the United States. Our hardware-as-a-service business model allows battery manufacturers to retain their material at no upfront cost. Yes, I said that correctly, no upfront cost. The battery manufacturer will not pay for our machine, but they'll buy back the active material from us after it has gone through our recycling process. Currently, battery manufacturers pay around $30 to $40 per kilogram for new active material. Recycling companies buy manufacturing waste from the battery manufacturing companies for around $12 per kilogram. On a prototype scale, it costs us around $7 per kilogram of waste to run through our machine. This allows us to make a profit of up to $21 per kilogram of waste. Now, you're probably asking yourself, how much waste do battery manufacturing plants produce in a year? The numbers are astonishing. In the US, there will be around 35,000 metric tons of waste in 2023. This number will almost quadruple in 2030, with there being around 140,000 metric tons of waste. On the graph shown on this slide, it shows the total addressable market from 2023 up until 2030. In 2023, there will be around $540 million of waste, and then in 2030, the number is going to be $3.7 billion. It is essential for direct recycling to capture this market to not only prevent the continued use of the environmentally hazardous recycling methods, but also help the U.S. in the transition to green energy. With the reduced rate of battery manufacturing around the U.S., the United States is at a crucial crossroad. Our application of direct recycling will reduce environmental harm caused by current recycling methods, reduce the mining of cobalt, which is associated with poor working conditions and child labor, and support the EV transition by helping manufacture economics and incentivizing accelerated growth. As manufacturing plants around the United States implement our machine, this will allow for new job opportunities for those who may have lost theirs in the energy transition. Thank you for letting us present in front of you today. Now we're open for any questions you may have for us.
Really nicely done. I don't know if you can hear me. Oh, there I'm on. I may have missed at the beginning. Is there specific chemistry this is designed for? And then the second is, you talked about the manufacturing waste, and you made it sound like you're taking cathode material waste. So is it just a specific step in the cell manufacturing process where you're capturing this waste, and how much of those billions of dollars is that particular step, or is that just for the step you guys are
That's
handling?
a fantastic question, right? So as you saw earlier, I think it was in the battery doctors, it's a $40 billion total market. So the numbers that we showed was just cathode electrode waste in the US. We did a lot of our own modeling from this based on the 120 customer interviews that we did. And to answer your first question second, we've done NMC, LFP, NCA, all of them. The economics work out particularly well in the case of LFP, as the previous team discussed, because the recycling value, if you use hydro or pyro, is so very low. The raw material value of LFP is basically nothing. So if you use direct recycling, it still has the active material value of $30 or $40 a kilogram. So now instead of paying to get it taken, we can actually give them a credit, and then it's also incredibly valuable in terms of the Inflation Reduction Act and meeting those minimum qualifications for domestically sourced material. One very, very important part that we think is going to play a major role.
And to add to that, we only recycle the parts of the when it's going through the line.
Oh, right. Yeah, sorry. So it's pretty much everything before rolling, before it's rolled into a cell and placed into it, all of which was accounted for in the numbers that we showed.
Thank you so much. I actually invested to kind of derived recycling, and then also Redwood is in our portfolio. So I wonder how do you differentiate it with other derived recycling companies like Lee Industries, which was co-invested with Coastla Ventures, and then also Princeton New Energy. So curious about your differentiator.
Yes, Princeton New Energy is an interesting one. They have a plasma-based process, which is a little bit above my pay grade. But they are not planning to do the idea is the business model is place a machine inside of a manufacturer's facility. Lee Industries is primarily focused on end-of-life batteries, and they have a lot of sorting technology. And then using a hydrothermal process like you just saw before to really relithiate the cathode material and then send it back. The thing about cathode waste is that it's in the condition that it was right as it was going into a battery. There's no relithiation needed. The idea is don't destroy the cathode material, so you have to rebuild it when it was just ready to be in a battery. So Princeton New Energy is an excellent, I just spoke with them at the International Battery Seminar. They have a great team, and I'm excited to see what they do, but it's a little different of an application than we are attacking.
So what would you say as your secret sauce? Like, I saw you have equipment over there. Could you elaborate on that?
Yeah, it's the solvent. It's an organic solvent, fully recyclable. Not to get too into the battery anatomy, we'd leave that to the doctors. But so it's the cathode is a current collector, aluminum foil current collector with PVDF and active material. PVDF is the binder. What the solvent does is basically selectively dissolves the binder, releasing the active material into the solvent. And we used a Hansen solubility parameters method to optimize that solvent for a specific type of PVDF dependent upon the manufacturer. So highly customizable to an individual manufacturer. And then you place the machine in their facility, and you're capable of producing cathode active material that can go right back into the machine.
Thank you. And could you talk about your business model? Are you going to sell the solvent, or are you going to kind of implement the equipment, et cetera?
Certainly, yeah. So in a hydro process, you could use a solvent to increase the purity of your input. We haven't looked too much into that market. This application is plenty large enough for us. But absolutely, certainly something that we could investigate is just selling the solvent on its own, yeah. Yeah, thank you.
Hello. Okay. I'm trying to clarify your business model. It sounded like you are a partner is giving you their material, and you're basically charging them to convert that material to usable material, and you're giving it back. Is that basically what you guys are doing?
Yeah, sorry, maybe we weren't clear. We currently have been in talks with Ultium. I'm good friends with Tom Gallagher, the COO there. They have a battery manufacturing facility in Warren, Ohio, which is right in our backyard. So exactly, they would provide cathode electrode waste, which is then processed using the machine that you saw, and we produce active material, which is then sold back to them.
Okay, so then you own and your technology will be on the facility side or your own location?
Located inside of their facility, right? The footprint of that machine that you
Got
saw is 6x4. It's not, it can fit on the stage up here.
So there's no need for transportation to another facility? Okay,
Precisely.
But you still own the equipment?
Yes, we own the equipment and we sell the active material back to them.
Got it.
Yeah.
So you're actually might be leasing their space from them maybe?
Exactly.
Or does that go
Yes.
into the price of what you're charging
Yes.
them to convert the material?
Right, leasing space. We also included in the $7 per kilogram cost, we included paying 2 workers, although theoretically it would probably be the battery manufacturer's workers that would be operating the machine.
Got it. Great.
So that $7 is a little high, but. Yeah.
Thanks.
Yeah, you're welcome. Thank you.
All right. Thank you so much.
You can go to Jackie. That's all.
All right, well, thank you, everyone. We are going to break for lunch, but go to the hallway, grab your lunch, take a bio break, and then come back to this room and eat lunch here. We're going to have our bonus prize teams give 5-minute pitches from 4 different teams that were selected from our bonus prize, and then return from there. So I encourage you to take a short break, grab lunch, but then come back in here to enjoy it. So I'll see you in a little bit. Thanks, everyone. Hi. Let's see. Am I ready? Can you guys hear me or no? Hello? All right, there we go. Welcome back from lunch. Hopefully you guys had some good food. For the next 20 minutes, we're excited to be joined by our bonus prize winners. So I mentioned earlier that in addition to the 16 teams that are competing today, we have 4 teams that were selected by the Department of Energy Program Office staff as bonus prize winners across a variety of technologies, from geothermal to large power transformers, grid enhancing technologies, and others. And we're excited that these 4 teams are going to share their solutions with you. So for each of them, they'll get just 5 minutes. There will not be Q&A, but you are welcome to come find them after their presentation and find out more about what they're doing. So with that, I'm excited to welcome Quantum Power Systems from the University of Texas at Austin.
Hello. Hi, good afternoon, everyone. My name is Adityan Vetrivelan. I'm a PhD student at the University of Texas at Austin, and today I'd like to talk to you about quantum power and what we're working on, which is solid-state transformers for the new electric grid. So what is the main problem that we're trying to address? In the past few years, American utilities have faced an unprecedented shortage of transformers at every power and voltage level. In the year 2020, the average cost of a transformer doubled, with wait time surpassing 1 year in many cases. At the same time, the average age of a transformer in the United States in service is about 38 years, which means a lot of these are going to have to be replaced soon. The problem with that is that transformer manufacturing is a very skill-intensive and resource-intensive project, and one of the main raw materials that goes into the construction of transformers is copper, and the global price of copper has been increasing due to increased demands for electrification as well as production issues in mines, and these are expected to last until the late 2030s. So how does this affect the clean energy transition? So here on this slide, we have a single line diagram of a utility scale PV generation power plant. So going from top to bottom, we can see the PV arrays would generate DC power at about 1500 volts, followed by an inverter system which converts this to AC power at about 600 volts. Finally, crucially, the PV inverter transformer, which steps this up to about 13.8 kV AC or 34.5 kV AC, depending on the system. So we can see that this entire system is very dependent on the availability of those inverter transformers, which are in short supply right now. So what is the solution? At Quantum Power, we believe that the solution is to integrate the inverter and the PV inverter transformer into one single unit known as the solid-state transformer, or the SST. So the SST consists of modular interconnected power electronics, which can perform the same function of converting the power from 1500 volt DC to high voltage AC as required by the system. The SST can operate at similar power efficiencies as that of a conventional system at about 98%, and significantly uses much less copper than conventional solutions. In addition to this, the SST also offers a direct DC port for integration of grid energy storage, which is becoming increasingly co-located with PV energy systems. So what does a SST look like? So this is what an SST looks like for modular power electronics converters, which are rated at about 1,000 to 1,500 volts, which are stacked up electrically to achieve the high voltage required by the AC grid. So this method of design really simplifies the approach, since we only have to design one module and we can scale up the number of modules required depending on the voltage level of the application. All of this is possible due to recent advances in silicon carbide technology, power semiconductor technology, magnetics, as well as system control. So on the screen right here is a 1 MVA 4.6 kV system developed by the team at UT. So we built and tested this system in collaboration with the Department of Energy as part of a multi-year project to develop the transformer. So here you can see how the individual components such as the magnetics and silicon carbide work together to give us the 1 MVA SST. So we've been building SSTs for some time now, and we believe right now is the time for commercialization. And over the next 2 slides, I'll talk about our competitors and why we think the time is right. So on the left-hand side, we have the traditional solution, which is a 3-phase inverter and a step-up transformer at 60 hertz. So the average price of this is $250 to $300 per kVA of power processing capability, if you can get your hands on it. So right now, these are not available on the market. Our prototype was costed at around $250 per kVA, but our next generation design, which is for 13.8 kVA, is aggressively cost targeted at $100 per kVA, and we believe we can bring this to market at $180 per kVA. So we're able to offer a better price while also circumventing the issues regarding the supply chain of the existing solution. So lastly, the timing. So as we all know, the US solar industry is poised for high growth. We estimate that between now and 2030, there's going to be $40 billion in cumulative sales of inverter-related equipment, such as inverters and inverter transformers. As I mentioned at the outset, the traditional transformer solution is heavy on copper, meaning they're going to experience an increase in price as well as shortage of supply. On the other hand, silicon carbide, which is the core of our SST solution, is being locally manufactured here in the United States right now, which means our prices are actually down and are expected to decrease even further. So this is our plan for the next few years. Right now, we're looking for $2 million in terms of seed round funding for team formation and really perfecting our next generation of our design for our module prototype. We're also talking to potential customers right now about prototype testing and what exactly their specifications are, and this is our roadmap going ahead. So this is our information, and yeah, thanks for listening. If you have any questions or want to chat, please feel free to talk to me.
All right, thank you so much. So speaking of transformers, I did learn of a Transformers joke from someone in the hallway. So why do transformers hum? Because they don't know the words. So our next team is Terry Goldsby from Visionergy, our Geothermal bonus prize winner. So she'll speak for 5 minutes about her company and solution. Welcome.
Thank you, Joe. Good afternoon. My name is Terry Goldsby. I'm the foundress of Visionergy and a junior in material science at the University of Maryland. Visionergy looks out and sees that the existential threat for the future is heat. So by 2070, there will be 67 cities worldwide that will suffer heat stress more than any human has ever suffered in the past. So it not only affects humans, it also affects animals, and specifically cows. So almost almost $900 million of loss a year comes from heat stress in lactating bovine. So the heat stress causes mortality, morbidity, and reduced milk manufacturing up to $2,500 a cow. It also suppresses immune function, decreases fertility, and leads to epigenetic problems through the generations. What a cool cow looks like is they lay down, they eat, they create heat, and they make milk. A stressed cow stands up because the heat comes from their bellies, and they're standing up to expose more surface area from their bellies to get cool. So while they're standing up and bunching, they stop eating, they stop making milk. The current technology says that you have to stop the black bulb heat by putting animals under cover. They also have to drink 50 to 75 gallons a day. And when the temperature reaches 73 degrees, dairy people use 36-inch fans and shade. At 80 degrees Fahrenheit, they add water spray for evaporative cooling. The typical system uses 25 gallons of water per day per cow. So that current technology in the West with its with the drought, 25 gallons of water per day per cow isn't going to work. It also happens that in the subtropics, where there's no evaporative cooling, it won't work there either. So Visionergy's solution is to pump the 55-degree cool from underground, under the frost level, pump it up, and then for these particular cows, to just insert it into concrete under the slabs where the cows live to cool their underbellies. So there's an alpha test that should cost about $52,400, and the basic price of that is excavating, which is an insurance for excavating. And the water that's used in these geothermal tubes is permanent. It doesn't get sprayed, it circulates. It's a completely closed loop system. A prototype is going to cost $1,400 for the HDPE, $2,100 for a pump, and we already have just a sample of copper tubing. I want to thank Energy Tech Up Prize, the 2022 win that Visionergy got helped seek partnerships with Virginia's indigenous tribes. We have an angel investor that's funding the prototype. It won a Dingman pitch competition at the University of Maryland, and it's a candidate for a startup shell. And finally, there's 2 pending patents for the system. So who's going to buy? So dairy insurance companies will lower their rates for dairy performers that use this technology. USDA indemnifies dairy farmers for their failed milk products. And both of them, the commodity futures markets should be supporting Visionergy's technology. The threat is these guys put in 5 to 6 ton fossil fuel fed air conditioning units to cool their cows, and it turns out that threat yields an 85 times more carbon emissions than the current fan and water spray. So this technology will be somewhere in between there, and I want to thank Tech Up Prize for acknowledging that no one's ever thought about using the ground cool. So thank you.
All right. Welcome back. It seems like people are finishing up lunch, but we have 2 more of our bonus prize teams to go. Next is our water power bonus prize winner, Magnetic Gears for Wave Energy from Texas A&M University. Welcome.
You know when you want to start driving your car, the first thing you have to do is you got to put it in gear. Gears are essential to many platforms, from aircraft to oil and gas applications to wind turbines. And regardless of your application, whether you're in an everyday environment or in an extreme and harsh environment, you need a gearbox that never fails. Fluxworks is creating non-contact, lubrication-free, self-healing magnetic gearboxes that put a new spin on this essential technology. We've demonstrated experimentally over 99% efficiency, that they're 4 times quieter than equivalent mechanical gears, and they can unlock unprecedented reliability from the harshest applications, from outer space to under the sea to inside the human body. And while we've conducted over 100 customer interviews in a range of industry applications, one of the most appropriate beachhead markets where we're targeting first is actually the wave energy market. This is an extremely fast-growing market where we offer an enormous value proposition, and it also paves the way for us to expand into multi-megawatt applications next. So who specifically are we targeting? It's like it got stuck and held down on it. Imagine, my pitch coach says to say the word imagine a whole lot, so I'm going to say imagine that you didn't see that. So, who exactly we're selling to is original equipment manufacturers. These were a few examples of customer interviews that we've spoken to. It's important to catch the wave now. I can slip in jokes because we've already won the bonus prize. And specifically, it's the 2023 to 2025 timing. And why it's so important right now is Biden's $1 billion bipartisan infrastructure bill has $1 billion set aside specifically for these targets. Additionally, it's important that we catch wave energy OEMs at the beginning of a new product life cycle. We're kind of the core and the heart of the system. It's not a widget that you can add near the end of product development. And why would they ever choose us? Well, it's a surprise to all. I don't know what's going on anymore. Can I get a help up here, or? Yeah. Let's see if I can click. Sure. You want to advance about like 5 slides? Yeah, this one's good. Let's just hop in. So what we're going to do is we're going to do product sales. We're going to manufacture them on our own. We've built prototypes, numerous over the past 13 years. With your help, we need to scale manufacturing capabilities, land strategic partnerships, and develop industry contacts. Some reasons you can trust us is we're a US-owned and operated business. We're HubZone certified, and we already have traction in defense and space applications. Next slide, please. Working with GE, we calculated that we can reduce the levelized cost of energy by as much as 20%, which is going to increase return on investment of wind turbine projects. Additionally, 1 magnetic gear outlives 3 mechanical ones, helping to alleviate the supply chain shortages. And then lastly, magnetic gear integrated generators actually use 22.5% less rare earth material than direct drive wind energy generators used currently in offshore. So if you'd go to the next slide, if all offshore wind turbines were installed using magnetic gear integrated generators, then that would result in saving over 100,000 tons of rare earth material in future applications. Here's an example of 2 side-by-side generators, one magnetic gear integrated, and the other one direct drive. Next slide, please. I just submitted my dissertation 3 weeks ago, so I'm now Dr. Brighton Preslika. My team involves Craig Newman. He was formerly NOV. We call him the real adult on the team because he had a real job for 12 years before he came and worked for Fluxworks. And then lastly, we have Dr. Matthew Johnson, former Army Research Lab engineer. We're looking for a CFO to support us at this time. And if you could advance to the next slide, we also have a web of mentors and consultants that we work with to support us in other various needs. And again, we still need a dilutive capital member to support us. And if you'll advance to the next slide. So where we are today, in our first year of incorporation, we got $57,000 in cash prizes, $1.65 million in government grants, and $7,000 in industry R&D services. Our 6th full-time employee began today, and also we do have offices and prototyping and equipment space. So what we need next, if you would advance just one slide, is 164,000 by July of 2023 to finish all of our patent PCT conversions. And then additionally, if you'll just advance the next few slides, we can close out since I believe I'm over time. These are just some of our commercialization targets in order to eventually capture about 5% by 2023 of the wind and wave energy market. Thanks, and I'll be in the back if you have any questions.
All right, so we have one more bonus prize team, then we'll have a short break before returning for our final 4 pitches. So our final bonus prize team is going to be Team RLGrid from Cornell University and Massachusetts Institute of Technology. So I'll look for RLGrid to come on up and grab a microphone and clicker, and we'll go from there. But welcome. Thank you.
Hello everyone, I'm Nolan Clement, a freshman from MIT studying AI, and this is Yanni Columbus, a freshman from Cornell studying computer science. And today we're going to be presenting RLGrid. So RLGrid was born by observing a simple problem. Renewable energy sources increase the complexity of the power grid due to their variable output. And as a result, independent system operators are struggling to adapt old planning software, which was written in the 1970s, to new problems, which is the reliability forecasting for these new variable renewable energy sources. So who pays for these reliability issues? ISOs manage the electric grid, and they pay hundreds of thousands of dollars per year collectively for planning software that works with declining efficiency. Additionally, any blind spots can be extremely costly, as outages cost billions. Once we had identified a problem and understood who pays for it, we rushed to speak with our potential customers. We spoke to the Director of Operations Policy at the California ISO and the Manager of Economic Planning at the New York ISO. Here we learned several key facts. First, the somewhat arbitrary standard for grid reliability is 1 blackout in every 10 years. It's important that ISOs have accurate forecasting technology so they can ensure that they are in this threshold. Also, current reliability forecasting software uses Monte Carlo simulations. This was great for us because both Monte Carlo simulations and modern machine learning techniques suffer from non-determinism. Finally, ISOs realize their software is not scalable or adaptable to modern variable renewable outputs. What if we could enhance mathematical models with the power of artificial intelligence? Enter reinforcement learning. RL agents learn through billions of iterations to find an optimal strategy, often achieving superhuman performance in a controlled environment. Reinforcement learning has mastered chess, Go, team esports, and even plasma containment for nuclear fusion. So why not the power grid?
So our solution for ISOs, RLGrid. We simulate grid topologies using Grid2Op, an open source grid operating platform, and we introduced an RLGrid reinforcement learning agent powered by AlphaZero. And this is the same algorithm that Google has used to conquer games from chess to Go. And literature use in academia has already validated that this can be used for grid stability. And essentially you create this game that an RL agent can go and play itself billions of times. And the game is to keep the power grid alive for as many steps as possible. And the agent learns to model risk as it plays itself. So how much is RLGrid worth to ISOs? RLGrid, from the literature that we studied, can produce up to a 10% grid stability and resilience output, which saves billions of dollars, according to the Electric Power and Research Institute. And there's even institutional support for a program like this, with the White House creating a $10.5 billion grid resilience and innovation partnership program. For RLGrid's first 18 months, we'll first go through research, implementing the latest results from academia and making sure we can reproduce them ourselves. Then we'll go into development, building a robust interface and testing suite. And then with preliminary partnerships with the ISOs that we've already talked to and are interested in something like this, and running RLGrid on digital twins with those local ISOs. And then we'll go into production deployment, making a generalized adoption system. As for economic feasibility, our core cost is really just AI, which is at its core like matrix multiplications. So our pre-seed and seed funding will easily be able to handle our costs, and we estimate operation to be less than 20% of revenue. And companies like the California ISO have already shown that they want to use AI in their distributed systems, and this powerful risk management is going to save them from billions of dollars of damages. So it's not just AI for the sake of AI, which is a common trend. It actually increases profitability for the ISOs, which is an important part. For potential impact and successes, RLGrid makes it easier to model risk of these renewable energy and variable output sources of energy, which encourages initial investments in renewable energy sources. And the Electric Power and Research Institute values a smart renewable grid at $2 trillion, and this is a vision heavily supported by RLGrid. In terms of national security, the RLGrid helps the US stay competitive because countries like China are already using AI to power their grid and do their grid management. And it also helps our infrastructure be stronger against cyber-based attacks. In terms of equity and safety, by increasing reliability, we can help impacted areas and more socioeconomically disadvantaged areas keep power reliability constant. Thank you for listening.
Thank you so much. All right, so we're going to take 10 minutes to reset from some lunch and lunch presentations, and we'll return for our last 4 teams at 1:15, and then we'll be done by just about 2:15 when the rest of the conference will resume and our judges will deliberate. So quick 10-minute break, and we'll be back in here for our final 4 teams. Thanks, everyone. So hello, everyone, and welcome back. We are going to begin now with H2 Ceramic Solutions from Prairie View A&M University and the University of Houston. Welcome.
Hello, everyone. We are H2 Ceramic Solutions.
In order to reach Paris targets, the U.S. must reduce GHG levels by 26 to 28%.
Yeah, in 2022, GHG emissions in the U.S. increased by 1.3%. If the U.S. is to get serious about achieving net zero and eventually net negative, we must deploy all carbon reduction solutions.
Ceramic Solutions, we have developed a go-to market strategy for a ceramic membrane technology created by Argonne National Laboratories that will dramatically increase the production of hydrogen efficiency and adoption, which will position us to be leading players in a growing hydrogen market.
My name is Anissa Hassan, and I am a third-year finance scholar at the illustrious Prairie View Agricultural Mechanical University.
My name is Annika Gill. I'm a computer science major at the University of Houston.
My name is Tonisha Bloomingberg. I'm a senior mechanical engineering major with a double minor in supply chain management and mathematics studying at the Prairie View A&M University.
The adoption of hydrogen has been slow due to high cost of production and distribution. But at H2 Ceramic Solutions, we see right now as a strategic time to bring blue hydrogen, better understood as hydrogen from natural gas, to scale, because it is a low cost and low carbon intensive energy alternative that is currently in high demand to meet emission targets. And also has the potential to be a catalyst for longer term renewable energy alternatives. Blue hydrogen is cost effective because it is currently trading competitively at $2.50 per kilogram, which is still more than oil, but less than its direct competitor of green hydrogen. This is also a great energy alternative because hydrogen can be used as a clean burning fuel source and electrical power source that produces only water vapor as a byproduct. Hydrogen is also currently in high demand and expected to account for 14% of the global energy mix by 2050. And according to the Hydrogen Council, we will need 660 million tons of hydrogen in order to meet emission targets. And ultimately, blue hydrogen makes sense as a stepping stone to cleaner hydrogen production processes because it is less expensive since it relies on existing infrastructure and can be produced at scale more efficiently with our ceramic membrane technology.
This Argonne Lab patented tech begins with the collection of the feed gas. Then a synthesization process occurs once passing gas through the ceramic membrane. Finally, the gases are either released back into the environment or stored for later usage, such as the blue hydrogen extraction for a fueling source. Blue hydrogen is the least expensive to produce in the world of hydrogen, especially with this tech. Hydrogen is one of the smallest elements in existence, are created from a composite concrete that can tolerate temperatures up to 900 degrees Celsius. The higher the heat, the more production of atoms are passed through the membrane, and the more accurate the hydrogen concentration. Although this tech has many economical advances, one of its limitations is that the feedstock derives from a non-renewable resource. But Argonne Labs has already developed a second membrane that will recycle the oxygen released during the process and circulate it back into the feedstock. This tech is effective and requires less resources than competing hydrogen extractions.
The global hydrogen market is currently worth $160 billion with an expected compound annual growth rate of 10.5%. Our sample addressable market consists of corporations that H2 Ceramic Solutions have identified as key partners that have pledged over $12 billion in their capital commitment to decarbonize their respective industries. We have identified our sample obtainable market by analyzing the hydrogen demand market here in Texas. Texas is positioned to be the world's epicenter of hydrogen production. This is expected to provide an additional $100 billion in economic value to the Texas GDP by 2050, according to the Houston Energy Transition Initiative.
Our business model still focuses on partnering with industry-leading companies that have an innovative vision to improve the sustainability of their operations. We plan to accelerate the adoption of our ceramic membrane technologies by partnering with existing hydrogen production facilities, which will reduce our construction time and capital expenditure. In addition, our business will specialize in connecting hydrogen facilities with energy-intensive companies seeking alternative power sources. We will charge a green premium for our membrane technology and consulting services, which will include supporting offtake agreement negotiations, maintenance and installation, carbon capture and sequestration strategies, and creating unique hydrogen transition business plans for energy-intensive corporations. Our company is proud to contribute to Houston, Texas becoming a global leader in the clean hydrogen production by strategically leveraging the state's existing infrastructure of natural gas, hydrogen, and CO2 pipelines. Transporting hydrogen through pipelines is not only the safest method, but also the most cost-effective way to transport it regionally. Our hydrogen will power critical infrastructure such as data centers and fueling stations for long-haul transportation, creating a more sustainable future for our communities. In addition, we will ensure that our carbon footprint is minimized by transporting and sequestering the byproduct of CO2 to existing salt caverns here in Texas. Our commitment to regional operations and sustainability makes us the ideal partner for companies looking to make a positive impact on the environment while also driving economic growth. To secure strategic partnerships on the consumer-facing end of our business model, we plan to leverage the hydrogen clean energy tax advantages passed in the Inflation Reduction Act. It's imperative to capitalize on the IRA now because the reason hydrogen hasn't been successfully brought to scale is due to its lack of price competitiveness compared to fossil fuels. However, with Section 45Q, that awards carbon capture credits up to $85, and Section 45V, which awards 60 cents on the dollars tax credit for hydrogen production, can help our target markets of long-haul transportation and data centers achieve their net zero goals. Our team has identified Chevron as a potential strategic partner due to their commitment in investing $10 billion in building a new hydrogen production facility in 2021. Their facility is expected to produce 150,000 tons of hydrogen per year and reduce 5 million tons of GHG by 2030. But with the application of H2 ceramic membrane technology, which has proven to increase hydrogen production by 32%, we anticipate contributing an additional 48,000 tons of hydrogen produced and reducing another 1.6 million tons of GHG emissions. We have conducted a cost analysis based on a 2005 study of ceramic membranes from the national laboratories adjusted for inflation. We plan to sell our ceramic membranes to hydrogen facilities for $939 per square foot, which includes a 50% markup from the manufacturing price to reflect cost savings that facilities will experience from using our technology.
Chorus Tech is a world-leading ceramic manufacturer and a substantial competitor for hydrogen production using ceramic membranes. However, when we compare their technology to that of H2 Ceramic Solutions, we notice a significant difference. While Tech produces proton ceramic membranes, which are electrochemical energy converters, H2 Ceramic Solutions manufactures ceramic and hydrogen transport metal, which have a unique two-step economical solution, meaning we produce both syngas and hydrogen. On the other hand, Tech utilizes natural gas, biogas, and ammonia to produce hydrogen. But diving deeper into the business model of both companies, we can see that H2 Ceramic Solutions has a definitive mission statement focused on building strategic relationships with energy-intensive companies and prioritizing environmental equality through carbon capture projects. In contrast, Tech's mission statement is more general and doesn't highlight any specific focus on environmental sustainability. This could demonstrate H2 Ceramic Solutions' commitment to sustainable practices and its alignment with the values of companies that seek environmentally responsible solutions.
At H2 Ceramic Solutions, we understand the urgency of addressing climate change, which is why we are committed to ensuring that the benefits of adopting cleaner energy alternatives are accessible to all. In addition to traditional carbon capture and sequestration strategies, we plan to institute urban forestry programs to further support the capture of carbon, which is a crucial step in the blue hydrogen production process, making this an opportunity for companies to give back to communities that have been disproportionately affected by climate change. And we are also pledging to reduce a minimum of 6 million tons of GHG per hydrogen facility partnership. Additionally, because we plan to retrofit existing hydrogen facilities, H2 Ceramic Solutions will be supporting the existing economy by retraining instead of displacing an immediate workforce. We believe by working together, we can make a positive impact on the environment and the communities that we serve.
To wrap up, there are 3 critical points to be taken away. 1, H2 Ceramic Solutions manufactures membranes fabricated from ceramic and hydrogen transport metal that provide an efficient process for separating hydrogen from fossil fuels. 2, we plan to partner with industry-leading companies, leverage existing hydrogen production facilities, and offer consulting services that focus on hydrogen transition plans. And 3, our business prioritizes sustainability and environmental equality. So ladies and gentlemen, in the past, hydrogen wasn't our gas, but now it is our future. Thank you.
Really nice job. Just a couple quick questions. Make sure I understood the plan is to make the membranes and sell them to folks like Chevron or other hydrogen producers, and the consulting services would be to help them how to integrate that process into their facilities. And I wasn't sure I got it. What is the feedstock? What is the feedstock for this process? What are you taking in?
So the feedstock for this process would be methane and oxygen, mixing it to create the syngas.
Got it.
About Chevron as a target market. What's the opportunity for growth, especially with Texas being hydro center of the country? Can you talk a little bit more about that strategy?
Yeah, definitely. So actually, Chevron's new facility that they are currently building out is also located in the Beaumont region. So it actually is still here in Texas. And because they are currently building their facility, we think this is a great opportunity to go ahead and insert our membranes since they're still in the process of building that facility. And this will give us good insight to what does the process need to look like for going into an existing facility and retrofitting to fit our membranes into their existing process.
Sorry, let me follow up. That sounds really great. Can you talk more about your, growth strategy after Chevron, or what other places you can see applications for this?
Yeah, absolutely. So outside of existing hydrogen production facilities, we first wanted to make sure that our ceramic membranes can be used in our first part of our business plan, which is at hydrogen production facilities. And then eventually we would like to tap into hard to decarbonize markets, which we have identified as long-haul transportation and data centers, which aren't currently being serviced by hydrogen. So bringing those customers to hydrogen production facilities would be our next step.
Great job, ladies. A couple questions. First, you mentioned that your 2 revenue streams would be H2 and syngas, correct? Is
I'm sorry.
What I heard? I thought I heard you guys say that you have 2 revenue streams, hydrogen and syngas. Is that correct?
Yes, sir.
It is, okay.
Well, you need the syngas to create the hydrogen. So manufacturing the membrane to produce hydrogen more efficiently is the first part of our revenue stream. And the second part of our revenue stream would be the consulting services in developing these hydrogen transition plans.
Okay, sorry, then that's good. And then secondly, can you say at what scale it's currently been piloted at, this membrane? Like what's the capacity it does now and what you hope to get it up to?
So currently we still are in the research and development stage of this. It hasn't been produced at scale. It has only been produced in labs. So we would need to do further research to figure out exactly how large they would need to be retrofitted to existing facilities.
I'm curious, how much does this membrane degrade over time, or do you have any sense of how long a membrane lasts and how often you might sell one membrane to one facility?
That is a great question. We are definitely still uncovering that in our research process, but yes, that would definitely factor in as far as how much we're going to price this at.
Yeah, maybe one final question from my side. So there are a lot of companies that are doing like membranes or kind of the full stack. How do you think that you can differentiate or keep your technology competitive in the market?
I think I know a way that our technology differs from others is first off of the concrete it is made out of. It's made out of a calcium titanite, and so also known as perovskite. So with that, and then also we are able to create our own syngas after the process of the hydrogen starts. We are able to recycle the oxygen back with the methane. So additionally, we're using less resources than other companies.
And that will significantly reduce the cost of how much it's going to cost to produce hydrogen, because syngas by itself is actually really expensive to produce, but the fact that our membrane is recycling and producing it itself will make it more economical.
Thank you so much. Thank you very much. All right, thanks everyone. And our next team is going to be Project Wildflower from the Oregon Institute of Technology. So I see some microphones and the clicker being handed off, and we'll invite them up to the stage now. So Project Wildflower, Oregon Institute of Technology, welcome.
Hello everyone, my name is Tony Augustine, and I'm here to talk to you all about Project Wildflower. I'm going to jump straight into talking about the Wildflower technology itself, and then move on to talking about the overall business plan. The Wildflower technology is a hybrid solar-wind device with the potential for application across multiple sectors. It can be utilized in those multiple sectors, and it's aesthetically pleasing, and it's designed to be sustainable from the manufacturing all the way to the decommissioning process. It's a modular device and has a vertical axis wind turbine, flat plate solar panel leaves, solar concentrating flowers, a lighting option, as well as in the future, a solar thermal storage option. These are some early preliminary models of the project. These have changed since the beginning of development and are going to continue to change as the project progresses. Moving into a market assessment for the device. Who are the potential buyers for this Wildflower technology? As I said before, it can be used across all those sectors. In the residential sector, it's designed to be economically feasible for the average homeowner, and General Housing Association rules have been kept in mind during the design phase for this to be possible, and it can also be used off the grid. When it comes to the commercial sector, due to its design and scalability, it's able to be used places where other technologies might be a little bit harder to implement, such as amid sidewalk plantings. In the public sector, it could be leveraged as a road lighting source, and it can also maintain an unobtrusive presence and a sleek look for things like hospitals or museums. Now, the active players in this market and competitors for this technology include other companies that sell hybrid renewable energy devices, such as Polar Power Inc. or GE Renewable. Now, Polar Power Inc.'s 2022 financial report stated that their third quarter, they made $1.7 million in revenue. And GE Renewable's 2022 financial report showed $68.8 billion as their market value. Other competitors for this include other renewable energy providers that might service utilities who could then service other home and business owners, such as the international company Siemens Gamesa and SunPower. And Siemens Gamesa's 2020 financial report showed that they were at $24 billion as their market value. And SunPower's third quarter 2021 market report showed that they had made $323.6 million in revenue. So you can see this is a very varied market depending on who the customer base is, what a company's marketing scheme is, and where they're choosing to have their entry point be. It's worth noting, though, that all these different competitors are really, for the most part, choosing to focus on one sector, be it residential or commercial. And the ones who aren't focusing on one sector are focusing on either pure solar or pure wind devices. And that means that the Wildflower technology can fit into a niche subset within this market. Now, the advantages of the Wildflower technology in business over some of these competitors who seem to be doing fairly well for themselves is that it's not pure solar or pure wind. And so it's not going to be subject to the same issues with intermittency that those types of devices can see. The system is also, like I said before, designed to be aesthetically pleasing so it can appease those general housing association rules. The lighting source option I mentioned also gives it that unique opportunity for a dual-purpose device that many others simply don't offer. And since it works on a vertical axis, it moves at slower speeds and is of little danger to wildlife and causes little to no noise pollution. Other devices of a similar nature also don't often have contingencies and plans in place for the end of the device's life cycle. But that's been a really big focus since the beginning of the design phase for this project. And in fact, the company plans to offer a decommissioning rebate, whereas then we would retrieve or ship back the old devices for recycling, and the customer would get money towards a new replacement system. That makes sure the customer and the company are staying environmentally conscientious, and that we're also incentivizing return customers. We also have a primary goal of increasing our use of renewable energy across all the markets. We have secondary goals of doing so in a sustainable and economical way. So we want this product to be as recyclable as is feasible, and we also want to have a fund for low-income families. And I'll talk more about those later. Now, how are we going to find customers? We're just starting out, so we want to have a comprehensive company website that's going to have system and device information, a pitch video, and contact information in general. We also want to send out regular company newsletters that are going to include product device information, updates during our development, and attend more outreach events and conferences to do more fundraising. We also want to have a variety of social media accounts so that we can generate more interest in the business and its goals, as well as the product itself, and that we can get also community feedback on this, since this is a very customer-focused product. And once we reach the manufacturing mobilization stage, we want to make announcements through our various social media platforms to get the news out through news outlets as well as energy-focused magazines. Now, the economic feasibility of this device. Are the costs worth it for these customers we're trying to contact? A pure residential solar system costs on average $12,000 to $35,000 USD, before any tax credits are applied, of course, and pure wind systems are costing even more. A current prototype of the device is being constructed, and costs are at approximately $550 for one device. It's estimated you would need about 5 of these devices to power an average American home. So adding those 5 devices together with some additional costs for better materials, the things you would need to actually hook it into a residential home, and product for ready deployment would cost about $6,500 to $7,000 to manufacture. So then we could sell it for a modest $8,000 to $9,000 USD on the low end. That means you can make a profit of $1,500 about. That's 2/3 the low-end cost of a pure solar system, making it economically viable for a very large customer base and allowing for widespread usage and great profit margins. We have 2 other models we additionally want to sell for the modular aspect, our Golden Poppy model, and that's going to have our modular lighting that's going to meet at whatever the customer's needs are, and our Star Lily model, and that's going to have the modular lighting as well as our solar thermal storage. These models are both under still research and development. Now, how is this business going to become sustainable, and what do we need to get up off the ground? We want to spend 1 year full-time prototyping and testing the device, and for that, we need about 5 full-time employees being paid between $32 to $36 an hour, a mix of engineers and a social media and marketing manager. At $50,000 for the actual system costs, like I said, this is not costing that much to actually prototype this, and then $10,000 for our patent application and a lawyer. And the total basic funding needs come to about $400,000. We want to get most of that from fundraising at events like this and grants. Now, once the deployment begins, if we assume the pricing scheme is the same, like I said, we would make $1,500 profit off of our base device, the wood sorrel. So if we assume that I got no fundraising and we got no grants for the entire company, we had no angel investment at all, we would have to service 267 residential customers to outsell our startup expenditures. Assuming a minimum of 20 customers in our first year, a very modest amount but a very feasible amount, I already have about 15 who are interested in my hometown. And then a subsequent customer base growth rate of 20 to 40% each year, we could get to that number in 6 to 7 years. And that does not include if we were to have a more diverse customer base of commercial and public sector customers who would have a larger profit margin. That also does not include if we were to have additional employees. So that if we had more employees than just me continuing the business after the 1-year prototyping, it would be closer to about 10 years for about 3 employees. Now the potential impact. In the short term, for the customers, they're going to gain that energy independence. They're going to get energy tax credits, blackout protection. The low-income families are going to be able to apply for the fund to get free or reduced cost wildflower systems for their home. The company is going to be able to develop more robust technologies and gain further support. However, in the long term, this technology is going to be able to ease the switch to renewable energy because it can be utilized in such a variety of ways and across such a variety of sectors. And it can supplement decommission. It can do so without making things super difficult and super daunting to a customer. Now, our true business outcomes that we're wanting to see, our overarching goal, like I said before, would be seeing this technology garner greater interest across those energy markets and adoption. For that to be attained, we need that fundraising money, we need that grant money and investment, and hopefully partnerships as well. And that goal is going to be accomplished when our manufacturing and mobilization stage has been reached. And we also have 2 secondary goals. We want to have this wildflower technology be as sustainable as possible. And for that, we also need further research and development. And that goal is going to be considered reached when our wood sorrel system has reached 85% or more recyclability. Our other secondary goal would mean that renewable energy is attainable for people from all walks of life. And for that, we want for that to be truly accessible, we want to have 5% of all proceeds after the company has reached a stable profit point be placed into a fund for low-income families where they can apply for it. And the measurable outcome of that is that at year 8 of the business plan, after it reached a stable profit point, that we would have serviced 200 low-income families with wildflower systems for their home. And that has been Project Wildflower for your consideration. Thank you. And I did see some of my slides got cut off. They were fine during the practice run when I came the other day, so I'm not sure what happened there, but if there is anything I need to clarify because they were cut off, just let me know.
Hey, thank you very much. Appreciate that presentation. So the thing that we're looking at, is that the first product that you called, I forget the name of it.
The wood sorrel. So yeah. Wood sorrel, all of them are based on flowers that are native to the Pacific Northwest.
And what is the anticipated power output of that device?
So the anticipated power output, so each of the panels on the low end, we're hoping to produce at least 100 watts from each of the panels. And then for the actual wind turbine on the low end, again, we're hoping for it to produce at least 300 watts. And then we'll also have the solar concentrators that are going to be on there. They're not included on this model here. They're not pictured there. Those are unknown right now what those are going to produce. Because of the fact that I just now, about 3 weeks ago, wrote up an official agreement. That is a patent that belongs to my project advisor, Dr. Feng Shi of Oregon Institute of Technology. Him and I wrote up official agreement for my use and the ways that I can use that patent of his. So I have that official agreement now written and signed from him. So now I have a permission to continue to include that in my design and use it in my prototyping. So before I didn't have all the data that I needed for that. But now I can move forward with that and continue to use it.
Great job. A couple questions. First, idea how large it is physically?
So the currently in the model, the prototype that I'm building is 18 inches diameter. Which is on the small side, but like I said before, it is scalable. So I can just go into my programming software that I've used for the 3D modeling and scale it up if I need to, and that's designed to be that way, to be scalable. But on the small end right now, I'm putting it into literally my parents' garden. So I designed it to be 18 inches across, and it can be as tall or as short as it needs to be as well. It's on a single pole support at the moment because it's on the short end right now. So the supports will change as it gets taller.
Got it. And then secondly, you mentioned thermal storage.
Yes, that is, sorry, continue with your question.
Yeah. So, why? And then what are you thinking of the medium for the thermal storage?
Yes, so the thermal storage comes from, because I'm using solar concentrators, and the solar concentrators in particular that I'm using create a lot of waste heat. And so it's something that is was already going to be a portion of the system that was just going to be getting taken off with heat exchangers because I was just going to be using multi-junction cells for the power. And so I was going to just collect all the heat that was coming and using it in solar thermal as a potential. However, I am not someone who has done a lot of energy storage research. That is something that was coming from one of my project partners who has since left the project because he had to move cross-country. So I'm looking for somebody who could come in and potentially advise on other energy storage options or on that as an energy storage option in general, just wanting to add some sort of other energy storage option to the system to make it more stable power generation.
I'm curious if you've been speaking to customers and what you've been hearing from them.
Yes, so I have, like I said, I have talked to some customers in my town that are potential customers, and a lot of them gave me advice on things such as safety, because if it's something that's going to be going in or around their home, a lot of them have children, and they were like, well, is it going to be spinning fast enough to hurt my kids? And so that's something I'm taking into account while I'm doing my testing. I'm going to be analyzing how high it needs to be above children's heads so it's not hurting people, or how fast it's going to be going. So that was one factor, is safety. Another one was, is it something that your team's going to have to come out and install for us, or is someone local going to be able to install it? So that's something we're factoring in as well. I'm hoping that the base device, the wood swirl device system, is something that a local electrician could even install. It could just be transported to a town and a local electrician could install it to make it easier and, again, less daunting to a customer base. So those are a couple things, some of the major things that I've gotten from customers I've talked to.
Thank you. That's fine. All right, so I do have one final joke. I think that's the last one on my list, is what did the solar panel say to the wind turbine at the conference? Wait, no. What did the wind turbine say to the solar panel at the conference? Hi, I'm a big fan. But I said it backwards to begin with. So, thank you. So our next team is Electromaim from the George Washington University. So we'll let them come to stage. Welcome.
Good afternoon. We're Electromaim. We install micro-hydro generators in buildings' water systems to save building owners money while drastically mitigating their carbon footprint.
Hi, I'm Dylan Casson. Born and raised in New York City, I grew up around skyscrapers, and for the past 3 years have been researching the energy efficiency and water distribution systems of those buildings. I've seen the impact that climate change has had and will have on my home, and that's been the main impetus for me to launch this venture.
I'm Emir Johnson. Similar to Dylan, I grew up in a city. I grew up in West Philadelphia, where things like climate change disproportionately affects people in my community, but little to nothing is done about it. So.
Hi, my name is Zoel Bublil, and I'm also originally from New York like Dylan, but I've been fortunate enough to grow up abroad, which has given me a real caring thought about international issues such as climate change, which affect us all, which is what brought me to work on this program.
Every minute, millions of gallons of water are pumped up and down the skyscrapers that dot our city skylines for getting a drink of water, washing your hands, taking a shower, or even going to the bathroom after downing a double espresso. For this water to reach the top floors of these buildings with adequate pressure, it first needs to be pressurized to extremely high rates using pumps in the basement of these buildings. However, if this water was just siphoned off to any of the units below the top floor, it would burst the faucet in half, break the toilet, or even injure a innocent shower. So, for decades, what building engineers have been doing is installing pressure-reducing valves along the height of buildings, as you can see here, to decrease that pressure to safe rates. Now, this depressurization occurs through the dissipation of that excess pressure, that excess energy, into heat, which means that every single time you open up a tap or you take a shower, you are wasting a significant amount of energy. And this net loss of energy is detrimental to our climate and the wallets of building owners. Now, this antiquated process wastes gigawatts of energy seconds globally. Now, to put that into perspective for you, 1 gigawatt of energy can power roughly 750,000 homes, or just under 10 million light bulbs. Now, this is where we come in. Electromaim installs and maintains microhydro generators to be used instead of those pressure-reducing valves. Our solutions allow buildings to cut back on energy costs or even profit on excess energy being produced by sending it back to the grid or repurposing it within their own building. Our solutions allow building owners to create a lot of money, get a lot of profit, while still allowing for adequate pressure in all of their floors. While pressure-reducing valves dissipate that excess pressure into heat, microhydro generators use that excess energy and collect it into electricity instead without affecting the pressure on any of the floors.
Our products can also be sold to fit into the natural replacement cycle of these PRVs to minimize costs, and our proprietary technology also constantly monitors the pressure, just like the original PRVs, to ensure efficiency and present malfunctions. Now, understanding that energy transmission and overregulation surrounding it has been one of the largest obstacles to renewable energy production in the United States and indeed around the world, our solutions cut out the need for large transmission projects by producing energy right in the heart of urban centers, where most of our customers are. Additionally, by producing renewable energy in these areas, we can protect low-income communities who are in an energy security risk by power outage that occur as a result of extreme weather or transmission issues. Furthermore, our solutions, which can save at minimum 4,600 pounds of CO2 per floor per annum, can upgrade energy security, resilience, and weatherization efforts in buildings while allowing our customers, the building owners, to profit immensely. Now, just to give you an idea of how big of a market we're working with here, there are over 297 ultra-high-rise buildings in New York City alone. And in a larger city like Hong Kong, there are over 512. This is a market of over $250 million in New York City and over $430 million in a city like Hong Kong. And that's not even talking about the over 6,000 high-rise buildings that would also turn a profit with our technology in a city like New York. From our market study of over 150 New York City and Washington, D.C. building owners and managers, we found that roughly 80% of them are scrambling for an energy-efficient solution or are currently settling for one that is unprofitable. Now, many of these building managers are still trying to recover from the unprecedented revenue losses that occurred as a matter of course due to the vacancies during COVID-19. Now, we actually benefit from this acute need because it's given us the unique opportunity to target these multi-tenant commercial buildings who are currently scrambling to find those alternative revenue streams that I was talking about.
Let's look at the South first. Let's look at an example. We use efficiency calculations from our engineering team. So given the Salesforce Tower in San Francisco, using the energy in that area, they could save upwards of $295,000 a year in savings. However, if the building had been completed 4 years ago, and if our solutions were installed, the building owners could save upwards of $1.1 million by the end of 2026 for doing nothing more than they already do. So additionally, if our solution was installed, they would also save 283,000 pounds of CO2 emissions annually. So just to give you an example, so pressure-reducing valves cost anywhere between $100 to $700 per unit. However, these pressure-reducing valves are replaced every 4 to 5 years and sometimes 10 years, depending on how big the building is. However, we come up with a solution to get rid of this constant need to keep replacing these pressure-reducing valves with an indefinite lifespan using our hydro generators. So our hydro generators, we would have a plan. We would have a maintenance team that has constant upkeep of the product, which would allow for us to, or building owners to stop, having to need to keep replacing their pressure-reducing valves. With this being said, we've come up with two solutions. The first one would be a solution for customers where they would pay $1,000 for the pressure for our hydro generator, as well as $600 for the unit price to keep that upkeep with the maintenance teams every year. Additionally, so we plan to come up with another plan in the future where we would allow for less or a reduced price for the building owners. That way, it would be a reduced price up front, and we would just in turn have some of that energy that is stored with our hydro generators.
So as you can see here on this slide, this is our profits and loss projections are based on 3 staggered project categories over the period of 2025 to 2027. Those include a pilot project, a mid-size building project, as well as an ultra-high-rise building project. Now, if you consider all of our expenses, from the salaries all the way to the cost of advertising, by the second quarter of 2027, we will have produced $24.8 million in profit, and this is all based on the profitability proofs that we have conducted on our solutions and verified in a lab.
Now, our competitors in the energy management technology field offer, quite frankly, very few profitable solutions at this scale. And quite frankly, those that are profitable, such as solar panels, often have a prohibitively long timeline to profitability and are expensive and, more importantly, often quite invasive to install. Our generators already exist, they've been tested, and the installation is quite simple. But no other company has taken the initiative to exploit the opportunity and create the necessary partnerships and knowledge sharing with existing manufacturers and installers to make this a profitable venture. Today, we have the opportunity to do that for the first time. Electromaim offers this inexpensive, simple solution to a massive market, which on this grand scale can create a substantive global environmental impact. We have 4 methods specifically through which we hope to bring our solutions to the market. Firstly, prioritizing sales to conglomerate property owners and developers, leveraging the pre-existing customer base of energy management firms, attending the conferences that exist our customer base, and partnering with corporations, municipalities, and cities to meet their individual ESG goals. Now, we have already identified energy management firms such as Gotham 360, building development firms such as JRM Construction, and other companies that are invested in NYC's LEED program as possible future partners. Our versatile solutions can and will create efficient energy production with estimated carbon emissions for a building of, let's say, 35 floors being over 73,000 per year saved. They will also help bypass these transmission obstacles, which will bolster energy security by mitigating resilience threats and building a system of microgrids, alongside alleviating the weatherization problems plaguing urban low-income communities where forced power outages are one of the key stumbling blocks to creating a higher quality of life. And furthermore, they will be tailored to our individual customers' needs, guaranteeing a minimally invasive installation procedure that will provide savings all the way from the building owner to the tenant level.
Now, we hope to hold a pre-seed funding round this spring and summer in order to finish our final stage of prototype development and then roll out our pilot installations, after which we hope to analyze those installations and use that data as the foundation of our first actual seed funding round, which we hope to have by the end of fall 2025, when we can roll out our sales process and implement our go-to-market strategy. Now, we know these solutions will not change the world in the blink of an eye, but they will be a vital part in trying to. Thank you.
Thank you so much.
Really nice job. Thank you. Just to make sure I understand, in a typical high-rise building, is there like one of these valves per floor? Are they per fixture, per unit? And what would be the kind of power output that you'd expect to get?
So if you're talking about an ultra high-rise building, which by certain definitions is over 75 floors, they would be approximately, depending on the occupancy, around 10 per floor, and then 10 for each floor. It's hard to really put kind of like a thumbprint of how much that would produce because of the differences in occupancy and sizes of different buildings, but yeah.
But in terms of the rating of the unit that you guys will build, what's the sort of peak power output if it's going full blast?
So right, it really, again, depends on what the customer needs, but we can produce anything from 100 kilowatts or lower all the way up to 500 kilowatts and remain in the same format size.
And do you grid tie this? In other words, you also have to include essentially an inverter to tie this back into the building's power distribution?
Yeah, so we would have to provide all of that maintenance and all of that installation costs, which is pre-built into the cost of the unit.
Understanding that may create higher costs, which we created that model in which we could have partial ownership of that energy for a reduced installation cost, as Amir mentioned a little earlier.
Great job, guys. I had a question about your kind of initial targets. So you talked a little bit about new building installation, which is probably a little bit more of a longer term, and short term. You talked a lot about New York, Hong Kong. Aside from some of these management companies, what is the incentive for some of these folks to pay money up front to kind of make this switch, put that investment in if it's not? I guess what's the incentive for them?
Well, I mean, beyond the incentive of saving a significant amount of carbon emissions per year, which is incentivized a lot via government policies and via pledges and things like that, there also is a significant monetary benefit. As Amir said a little earlier with the Salesforce Tower, just installing this could have them have savings of effectively $1.1 million by 2026. And so the monetary benefit is there, creating a passive income for the building owners. And so we believe that that will be a draw to the product, even beyond the environmental draw in and of itself.
Have you done any like a payback analysis on like the building owner or the residential owner? Like how, what was their kind of benefit cost analysis?
Are you talking about like when they will profit after? Yeah, so like the initial cost for 34, we based it off of a 35-floor building. So the initial cost would be around $560K just to install, and then they would profit by around year 4, and then by year 9, I want to say it was $900,000 they would be benefiting from. And just to answer your question before, we assumed around 21,000 kilowatt hour energy per floor. And that was based off of 85% turbine efficiency rate, sorry.
And what is the maintenance requirement? Like, have you done any like stress test on your equipment? Like, how long does it last? And do you actually need to have like maintenance operations folks like on ground?
Yeah, so with our first few prototype tests, which we completed this past winter and spring, we've kind of learned what we need to complete in this final stage of prototype development to really pinpoint those areas to minimize the amount of maintenance needed. But what we're looking at really, we've put all of the maintenance costs into the cost of the product itself, and we would be able to have a often enough maintenance program that it would essentially have a lifespan that would be infinite.
One last question, sorry. I'm assuming that the taller the building, the higher the potential energy output of these. So is there a minimum height where this just doesn't work for like smaller buildings?
Yeah, so we've determined basically anything above 10 to 12 feet, 10 to 12 floors can garner a significant profit from installing these solutions.
Got it. And then secondly, again, for very, very tall buildings, installing this and then all the wiring that would be needed, couldn't that be like really, really cost prohibitive once it gets too high? You follow what I'm saying?
So yes, but that's precisely why we have the program where we would essentially have lower upfront costs, and then Electromaim would own those a percent of the energy produced for a certain amount of years in order to get back on that investment. So that way we'd be able to lower the upfront costs for those customers while still coming out with the same amount of profitability for our company.
Furthermore, in those, when we do install these productions, we do try to do it when there is a natural replacement time for the existing pressure-reducing valves, which means that they would already have to be paying for a retrofit of their system to get new pressure-reducing valves, and this is an added benefit on top of that maintenance they would already have to be doing.
All right, we're just about at the end of the day, so we'll thank this final team. Thank you so much to the George Washington University and Electromaim, and for our final team, extra big round of applause for being the final team of 20. So we're excited for them to come up. Our final team is Carbon Busters from Purdue University, so we're excited to have them up on stage. Welcome.
Carbon Busters project tackles decarbonization of diesel fuel, which accounts for 8% of US carbon emissions. We do so by accelerating the path to net zero renewable diesel biofuel, which is a direct replacement for diesel fuel. Our project started a long time ago in a galaxy far, far away. When Han Solo couldn't get Millennium Falcon off the ground because Republic was out of diesel fuel. But Han came across a replacement for diesel fuel, which was renewable diesel biofuel. But there was a problem with changing the fuel. The issue was it could disrupt the supply chain. Then Han thought, okay, if I just change the label from renewable diesel to diesel, no one would even know the difference. So Han called Yoda and said, hey Yoda, I need some renewable diesel biofuel within 6 years because the Death Star is going to be here to destroy the Republic. Yoda said, proven our patent, we have not. US DOE SBIR proposal submitted, we have. Han said, oh, awesome. So once you've proven your patent, all you need is $50 million in capex, right? Then Yoda called Luke Skywalker for the $50 million. Luke said, I'll try to do it. Then Yoda said, do or do not. There is no try. May the Force be with you. We're Team Carbon Busters. I'm Jedi Nea Shakali with Jedis Amanda Lopez, Sharon Hughes, and Professor George Zhou. We use direct air capture from algae to produce our product, which is algae oil feedstock. During direct air capture, 1 gram of algae captures 2 grams of carbon from the atmosphere. This process is entirely risk-free and equipment-free. Then we produce our product, net zero algae oil feedstock, which we sell to our customers, renewable diesel producers, and they in turn sell this to oil refineries for end use in heavy and medium duty trucks, which accounted for 8% of carbon emissions in the US. For our revenue model, our biorefinery operates at 10 million gallons per year and a revenue of $65 million per year. Then we again sell this to oil refineries and they sell it to heavy and medium duty trucks. The main driver for our price is the oil refineries' carbon mandates. They need our renewable biodiesel to reduce their overall carbon impact. Our project is for profit and for purpose. Our investors make a lot of money and they feel good about it because they capture a lot of carbon and they create a lot of jobs for the disadvantaged. Here's our supply chain. We operate just like an oil refinery. The main difference is that for oil refinery, you have to drill for oil, whereas for us, we can grow our own raw feedstock, which is algae. Our process is patented by our Professor George Zhou, and this is more cost efficient compared to the other existing processes in the market. In this process, we use microbes to extract oil from algae and to produce our final product, algae oil feedstock. For product market fit, our solution was verified via 204 customer interviews during National ICOR. And the market validation was on steroids, as 9 of the top 10 US renewable diesel producers wanted our product. They all had a common pain point. There were no net zero feedstocks available in the market. As a result, they were unable to tap into the $15 billion market of net zero renewable diesel. So they all end up selling to the carbon positive market, which is currently overcrowded. For buying from our competition, there's always a trade-off between carbon reduction and price. For other algae oil, the price is too high. For oils like waste, corn, and soybean, the carbon reduction from diesel is too low. Whereas for us, there is no trade-off, as our price is the lowest and our carbon reduction is the highest. Moreover, corn and soybean are classified as food, whereas our algae is not. Here's our market size. Going from bottom to top, our beachhead is algae biorefinery number 1, operating at 10 million gallons per year, with an annual revenue of $65 million. Our SOM is 19 more biorefineries for a total of 20 biorefinery strategy with revenues of $1.3 billion. And our SAM is a $15 billion untapped market with a 2,000 million gallon per year mandate shortage. Shown left is the net zero market, which I've already discussed previously. And in the center, you can see that this market is regulated because all oil refineries are required to fulfill carbon mandates to reduce their carbon emissions from their diesel. And on the right, we see the benefits that our net zero feedstock offers to our customers. We offer the first mover advantage and also the premium price over the other carbon positive feedstocks. As a result, since 9 of our customers wanted our product, we had a pick of our Jedi Master. We picked Jedi Master Kenobi, meaning our algae oil feedstock off-taker. Our sales strategy is a joint venture between us and them. This JV is a win-win. It's a win for us because we get to lock down our sales volume and the sales price. It's a win for our off-taker because of the benefits. As a result, they wrote a letter of support for us for our DOE SBIR proposal. We have locked down the unit price of our product. We have also locked down the unit cost of our algae. As a result, our unit profit is locked down at $1.50 per gallon, which is 33% higher than soybean and corn oil. This is huge because other biorefineries have all failed as they were unable to lock down their unit profit. We can discuss more about this in the Q&A. Here's our cash flow. We require a capex of $50 million, and we already have 2 letters of support for our equity from 2 big off-takers who are basically going, they usually supply capex for much higher valued projects. And you can see that for our annual profit, we have a positive cash flow right from the year 1. And from year 3 onwards, we have a positive cash flow and a profit of $15 million per year with a 23% margin. We have 3 main sources of funds: our JV partner, the private sector, and the public sector. For uses of funds, we have 2 big ticket items. First are our algae ponds, which are going to be on 4,000 acres of marginal land. And the second is the algae biorefinery number 1 itself, which operates at 10 million gallon capacity, and it operates just like a water treatment plant and a biomass power plant. Over to you, Amanda.
Thank you, Nia. For beneficiaries, our algae biorefineries are beacons of hope across the world. One algae biorefinery supply chain captures 2.5 million metric tons of carbon over 25 years and creates 1,500 jobs. And ladies, who wants equal pay? We do, and we know that you do, and you do, and you do. That's why our first algae biorefinery will be the world's first gender equal biorefinery, meaning a 50-50 split of women and men. So for the same job, women receive the same pay. We play 3 roles in the energy transition. First, we capture carbon. Second, we create jobs to help the disadvantaged. And third, global expansion. We will start with biorefinery number 1 in Belle Glade, Florida. 1,500 jobs reduce the unemployment rate by 70%. 19 more biorefineries achieves our 20 biorefinery strategy, capturing 50 million metric tons of carbon and creating 30,000 jobs. then global expansion of our biorefineries across the world. For the business plan, we have the key to success, which is the synergy within our team project. This team is a joint venture between us and our off-taker, which is a multi-billion-dollar US renewable diesel producer. So here, notably, we have our team captain, Sharon Hughes, that led project teams on similar projects at British Petroleum, or BP. So for us here, our definition of success is to get algae biorefinery #1 off the ground. Finally, for resources and people we need, it is a domino effect. First, we need DOE SBIR grants to prove our patent. Then, dominoes kick in with a joint venture with our off-taker. Next, as mission control, our team project can get CapEx from our hero, Luke Skywalker, or which is the same, the investor. And finally, we can get algae biorefinery #1 off the ground, and in turn, can take the net zero renewable diesel to Han Solo, so he can defeat Death Star and save the Republic, or which is the same, our planet. Thank you very much, and we welcome your questions.
I'll go first. A very good presentation, and especially your off script and you're able to do that is brilliant. So my question is, algae oil, it has been, like many big companies have been looking at that. Exxon, I think they had a very, very big endeavor like years ago. So I think the efficiency is always an issue, like how you're able to scale up. And then you also mentioned like 4,000 acres for kind of your first field project. So that's a large land, and also just kind of the bottleneck on the scalability. Could you talk about how you're able to tackle that where the oil majors were not able to?
Yeah, so we were prepared for the question. Thanks for the question. So we will succeed while the other big biorefinery or big companies haven't. We have three main reasons. The first is the economy of scale. So as you can see, the other companies, they operate at a much higher scale, whereas we'll be starting small with 10 million gallon per year. And the second is the budget on marketing. So these big companies spent 33% of their total money on marketing, whereas we are going to spend 0% because of our JV. And the third is the location. The other companies grow algae in locations like California, which is a desert, and algae is not native to that area, whereas we'll be starting over in Florida, where algae is a natural resource. So we don't have to spend any extra money or extra resources to grow our algae. It's naturally grown there, so it should be fine for us. Did that answer your question? Thank you.
So just to follow up on that, I understand all that. The fundamental technology here, could you describe it, and why is it better than everyone else's that has tried this?
Yeah, so the do you want to? I'm just going back to the. Oh, sorry. So, yeah. So our algae biorefinery is basically going to operate as a combination of a water treatment plant and a biomass power plant. This technology has already been proven and it's being used in the market. Whereas for us, we are not proving any new technology. We are using it to produce a new product. So in a way, we are not doing anything that is that has risk in it. We don't have any kind of risk because the equipment is completely proven.
The actual algae, the biological processes or known processes, not some novel genetic modification of algae or anything like that?
Oh, the process itself is patented. Mm-hmm. So we use microbes to extract oil from our algae. So this process, we have proven it on lab scale. And we are going to work more to basically take it onto industrial scale and produce it at a larger level. That is the part where we have to prove our patent. And After doing the ICOR and also with the SBIR proposal, we intend to do that, basically proving it at a larger scale. Did that answer? Or do you want to add anything?
And just to interject really quickly, because I did the negotiations for the offtake agreement with the multi-billion-dollar company. We signed an NDA. They know what our patent is about. They believe in our patent, so we're on to something. And I've been exploring algae technologies for 10 years since I left BP. Dr. Joe is on to something, and it looks like it could be a real breakthrough because it's using technology that exists, using organisms that exist, but the use of them is different. So it's nothing new. So the risk is low. It's not there, but it's very low. And we used to do very similar things at BP. Just take technology and use it in a different way. Very easy, and we were successful every time.
You know, I know from my experience that scaling up has always been a problem in the biofuel industry. Can you talk about what's the largest scale this patented process has been demonstrated at? And secondly, how much land are you going to need for your full commercial scale deployment?
So 4,000 acres might seem like a lot, but the amount of algae or the biofuel that we are producing, or the algae oil feedstock, when you compare the amount of carbon that we are sequestering from the atmosphere and you compare it to our competitors like corn oil or soybean oil, it's on a much smaller scale. Like I would say magnitude smaller, because if you have to use the same amount of if you have to sequester the same amount of carbon or to save the same amount of carbon using corn or soybean, it's going to be like for producing 1 gallon, how much was it, Sharon? Do you remember the numbers?
We could produce, 1 acre does like 500,000 gallons.
So 1 acre of, you can take the question.
Okay, basically what we're saying is for soybean and corn or corn ethanol, they use 80,000 acres. You need to understand that. We're using 4,000 acres for 10 million gallons. And then for economies of scale, we're sticking with 10 million gallons, but we're doing 20 of them because we're just repeating what we do. So we're going to end up like the Titanic Exxon, but 10 million gallons at a time because it's safer. And that's the brilliance of how we're doing it. And again, this comes from fundamentals we lesson learned from BP, why you can do it that way. And typical Brazilian biorefinery is 25 million gallons. Typical US biorefinery is 80 million gallons. 10 million is the bottom end of the scale that you could use for economies of scale to work. That's why we're going with 10. Awesome. And it's because it's safer. Oh, sorry.
Awesome. Well, thank you so much.
Thank you. Thank you.
Great job. Hand it to Jack. All right, everyone. 20 presentations. Congratulations to all the students who presented. Thank you all so much. So for the students, now's a great time. There's a networking break for the Energy Thought Summit until 2:40. And then I highly encourage you to come watch their keynote speakers, watch their welcome. We will announce the winners of Energy Tech Up at 5:15 p.m. And then there'll be another networking break hosted by the Energy Thought Summit. So please do take advantage of this conference. Take advantage of all the speakers that are here. Thank you to Z Prime and Energy Thought Summit for hosting us, and do enjoy that activity. Judges, you now have more work to do. So I will take you in a moment to deliberate. But students, just such great work. We're so appreciative that you're here. If you haven't received one yet, or if you would like one for your student competitors back home, we do have these Energy Tech Up pins that you could add to a backpack, your badge, your clothes, whatever. Maybe it's easier for networking, maybe it's not. We have a bunch of extras. You can go find them with Hannah. And if you have not filled out our feedback form, the single piece of paper, we do really benefit from your feedback as well. So do find Hannah and fill that out. Thank you, everyone, and we'll see you again at 5:15. Yeah, so I think, ooh.